Hello there, and welcome to the planet's memory, a place where curiosity finds its own gentle pace, and science is allowed to wander without any hurry. Tonight, we're not racing toward answers, we're floating one thought at a time, through a question so old that even the planet itself seems to carry it like a hidden scar. What if we could step back to the beginning, before stories, before memory, before the first breath of life, and ask, what was Earth like when it all began? A question so vast, so haunting, that it feels less like searching for an answer and more like listening for an echo across an ocean. Before we drift further, I'd love to invite you into a small ritual of stillness. Where are you tonight, as these words reach you? Are you near the edge of the sea, where the air sometimes carries the taste of salt? Or are you deep within the continent, where water feels more like a memory than a presence? When was the last time you stood by water, by a lake, a river, or the surf of a dark shore, and let your mind fall into the silence of what might lie beneath? That soft moment of gazing, hearing only the rhythm of waves or the stillness of a pond. It is a moment that connects us to the same wonder our oldest ancestors must have felt. And if you find something comfortable in this slow way of thinking, I'd be grateful if you left a like or subscribed. It helps this calm shoreline of curiosity find others who might need it, too. Nothing here will ever be rushed. Nothing will ever be loud. Everything here will be steady, like the pace of tides. And so we go back. Not a decade, not a millennium, not even a million years, but far, far deeper, beyond fossils, beyond mountains, beyond even the continents themselves. Back to a world that is almost unimaginable. A world where the sky was not yet blue, where oceans were not yet alive, where no eye had ever opened to see. We are used to thinking of time in terms of histories and lineages. But here, time is neither. Time is stone and vapor. Time is silence. The earth then was restless, unruly, shaped by heat that bled from its core and by the endless rain of debris left from the making of planets. Imagine the ground itself trembling with volcanic fire, mountains rising not over ages but in single bursts of violence, then crumbling again under skies thick with carbon dioxide and methane. The air would not have been breathable. The seas, if you could see them at all, would have been tinted not by the reflection of blue sky but by the scattering of particles, heavy with dissolved metals and minerals. This was not yet a place for life, it was a stage being built slowly and at the scale of continents. Rocks from this age are scarce. Time has folded most of them back into the planet, through subduction zones and tectonic churn, recycling what might have been a first record into the Earth's core. Yet a few stones remain on the edges of Canada, Greenland, and Australia. Zircon crystals older than mountains, older than oceans, older than bones. In their atomic structures, in the ratio of oxygen isotopes captured within them, lies a faint whisper of something extraordinary. The presence of liquid water 4 billion years ago, perhaps earlier than we once believed. These crystals are not just fragments of geology. They are fragments of memory, the Earth's very first diary pages, written long before eyes and hands could read them. If the story ended there, with rock and water, it would already be miraculous enough. But the question that lingers like a pulse in the dark is, how did the lifeless chemistry of those early seas turn into something that could look back, could ask, could wonder? Was it lightning splitting the sky, striking boiling oceans and forging amino acids from chaos? Was it volcanic vents breathing energy and minerals into the crushing silence of an abyss? Or was it something gentler, molecules gathering upon the surface of clay, finding patterns that held just long enough to copy themselves, to echo into the next moment? No one knows the precise path, and perhaps that uncertainty is the gift. Because the not knowing creates space for awe. It creates space for us to imagine that the Earth itself held infinite experiments, countless fragile assemblies of matter, most of which vanished before the first true cell ever endured. It is not a tale of one beginning, but of many beginnings, nested inside one another, collapsing, trying again, until one form was not washed away by tides or burned away by volcanic flame. And when that first survivor came, whatever it was, wherever it clung, it carried with it more than structure. Carried time. A continuity so thin, so delicate, that if it had failed, we might never have been here. Each moment of our history, Each of our lives is tethered impossibly to that fragile survival etched into a sea that no longer exists as it once did. To hear this story is to hear our own heartbeat, older than life itself. And yet, even as we lean closer to these traces, even as science reveals the bones of the story through isotopes, through ancient geology, through climates long erased, what we discover more than anything is what has been lost. Records melted back into magma. Oceans boiled and cooled with no fossils to leave. Atmospheres that shifted and were carried away into space. For every fragment we uncover, there are thousands erased by erosion, decay, and entropy. Perhaps the greatest mystery of all is not how life began, but just how much of its beginning has already vanished, leaving us to imagine on its behalf. And if this much can be lost, if even entire chapters of Earth's story can be torn away by fire and buried under stone, then another question rises in the quiet. What would it mean if the memory of oceans themselves could tell us more? The first waters were without names, without maps, without stories. They were oceans that belonged to no one, seas that waited before language had ever risen from lips, before perception itself had eyes to see them. Imagine the earth wrapping itself in liquid silence, tides swelling and receding in patterns not yet measured, waves tracing invisible rhythms across a planet too young to know what rhythm was. The oceans were restless but also unimaginably patient, carrying within their depths a kind of unwritten potential, a chemistry that whispered slowly toward possibility. These were not the oceans we know. Their surfaces may have been darker, heavy with minerals and metals leached from new crust, their depths murkier, their horizons shrouded by skies thick with gas. To stand beside them, if anyone could have, would not have been peaceful. The air was sharp, almost toxic, yet the sound of water would still have been familiar. Gentle waves brushing stone, the sigh of tides cycling endlessly. Even then, even before names, water already carried the capacity to calm, to cradle, to shape. Its patience was not gentle or soft, but it was endless. Geology tells us that water may have arrived as vapor rising from molten rock, or perhaps it was delivered steadily by comets, icy travelers from the dark outskirts of the solar system. Maybe both. What matters is not which, but the fact that liquid water endured, circling, evaporating, condensing, seeping into stone and flowing back to sea. Even in those formless ages, water kept time, etching its presence into minerals, leaving isotopic trails that scientists read today like faint notes in an ancient song. Through these signatures, we see evidence that oceans existed billions of years ago, long before continents found their balance, long before life stirred. And within them, invisible dramas were already unfolding. Molecules drifted and collided, scattered and dissolved, only to touch again in endless variation. The water was a stage but also a voice. It carried chemicals across currents, dissolved salts into intricate solutions, concentrated minerals in shallow basins that dried and filled again. Over thousands, over millions of years, these simple but ceaseless movements built the conditions for complexity, for beginnings that were not yet living but already full of meaning. Think of how we see oceans today, a surface vast enough to overwhelm thought, yet shallow compared to the depths below. Now imagine those first seas, unknown not because they were unexplored, but because there was no mind to know them, no word to give them shape. In their quiet, chemistry was writing something profound in a language older than speech, older than memory. And still, it is almost certain that most of what formed in those waters was erased. Decay was constant. Entropy dissolved fragile arrangements of matter before they could stabilize. Yet out of countless dissolutions, something endured, clinging, forming, persisting. Could it be that every wave carried the possibility of life, washing countless times against volcanic rock, scattering possibilities into the deep and returning them again? Could it be that every droplet contained the beginnings of memory, waiting patiently until the right spark set them into motion? Or maybe the first steps toward life happened not in the open sea but in tidal pools, shallow and warm, full of evaporating salts, places where water became both cage and cradle, concentrating possibilities so tightly that chance could finally take hold. The patience of water is not like the patience of humans. It does not wait, it simply is, Tides rise not because they hope for change, but because the pull of the moon demands it. Rivers carve valleys not because they plan to, but because flow finds the lowest way. The same was true then. Oceans did not seek to create life. They were, and in their being, they gave rise to possibilities far beyond their silence. It's easy for us to imagine intention at the dawn of life, but maybe there was none. Maybe it was accident layered upon accident. Chemistry trying itself endlessly until one attempt lingered long enough to leave a trace. Maybe, or perhaps it is still happening now, in ways we cannot see, as waters touch minerals beneath our feet, running tiny experiments across infinite scales of time. And when we look at the oceans now, with their tides that mirror the cycle of our breath, it is deeply humbling to recognize that they are older than any living lineage. Older than bone, older than sound, older than vision. They hold within them the memory of beginnings but guard it carefully, erasing as much as they preserve. Their story is not just one of continuity but of loss, of entire possibilities washed away into silence. And yet, water itself remains, carrying its own presence forward, wrapping our present world just as it wrapped the first. To hold that thought is to feel the weight of deep time pressing gently against us, reminding us that we, too, are temporary shapes carried on an ancient tide. And if oceans could create possibility before there was even life to notice it, then what else might stone remember in its wordless silence? Rocks, at first glance, appear fixed and unmoving, but within them lives the longest memory of all. Every grain of mineral, every crystal lattice, every folded seam of mountain carries whispers of the world before names, before life, before breath. Stones are not simply solid. They are the planet's language, written slowly, rewritten endlessly, by heat and pressure and the shifts of time. To hold a rock in your hand is to cradle a fragment of deep memory, a shard of something that outlasts even oceans. The oldest stones we know are not layered with fossils or marked by patterns we could easily decipher. Instead, they are minerals hidden within the crust of places like Australia, Greenland, and Canada, small and unassuming, yet billions of years old. In those crystals lie scenes of vanished worlds, oceans long evaporated, atmospheres long shifted, deserts long buried. Their isotopes capture a chemistry we can no longer witness directly. The presence of water, the trace of oxygen, the metallic fingerprint of stars that died long before the Earth was born. It is as though each grain is an archive without language, holding silent testimony to events no one saw. But memory in stone is not permanent. Mountains rise and fall. Continents drift. Ocean floors are pulled down into subduction zones, melted, recast, erased. For every secret geology preserves, countless more are taken back into the furnace of Earth's mantle, recycled into new layers. The planet, in its restlessness, is constantly hiding itself, stripping away its own first chapters. We look for origins in rocks, and yet we learn just as much from the silences, from the erasures, from what isn't there. Could it be that entire epics have been swallowed whole, their stories never to be read? Could it be that even the memory of beginnings has been largely forgotten, locked away in stone that never returned to the surface? And yet, the fragments that do remain stretch beyond the scale of our imagination. A crystal of zircon, no larger than a grain of sand, might be 4 billion years old. In that tiny fragment, scientists detect ratios of oxygen isotopes that hint at oceans forming upon the newborn planet. In such a small shard, enormous epochs are implied. Rains falling on bare rock, rivers bursting through volcanic plains, tides carving shorelines that have long since vanished. Each stone carries timelines that dwarf our own. Where human memory fades within decades, and civilizations crumble within centuries, stone carries patience in spans of billions of years. It waits, always outlasting us. And this raises a quieter, deeper question. What is memory, really, if it is not the act of recounting? We often think of memory as something tied to thought, to identity, to a conscious mind. But perhaps memory is simpler. Perhaps it is anything that holds a trace of what has passed, any pattern that survives change. In this sense, rocks are the oldest living memory the Earth possesses, though they themselves are not alive. They are the echoes of eruptions, cooled into form. They are the fingerprints of pressure, folded into mountains. They are the records of heat, locked inside crystals that shimmer only under magnification. Memory, then, is not ours alone, it belongs to the matter that holds traces of time. Perhaps this is why standing before cliffs or canyons fills us with such a still kind of awe. The layers stacked before us are not just geology. They are stacked memories, one upon another, each a page of a book where most words have been erased. We read them in partial glimpses. A ripple in sandstone, a seam of volcanic ash, a buried pocket of minerals pressed under unimaginable force. Not because they tell us everything, but because they tell us only enough to remind us of how little we know. Maybe the silence of stone is itself a truth, reminding us that memory does not always share, that forgetting is just as much a part of time as remembering. Think of mountains, the Himalayas, young and sharp, thrust upward by the slow collision of India with Asia. The Appalachians, ancient and worn almost to nothing, once higher than Everest, now softened by eons of erosion. Both landscapes are made of stone, yet each carries a different memory, a different stage of existence. The young rocks carry sharp scars of violence. The old ones carry the weary smoothness of loss. Both whisper to us if we listen, though we must accept that what we hear is fragmentary, echoes from chambers half collapsed. If erosion is the language of forgetting, then fossils are the small exceptions, the rare moments when memory is fixed briefly in stone. But in these earliest chapters of Earth, before life itself had begun, there were no creatures to leave behind their shapes. The rocks of that time tell us instead of heat, of water, of gases, of fire. They remind us that even before breath or blood, the Earth was already keeping record. Not because it wished to, not because it cared, but because matter cannot exist without carrying its scars. And so, as we trace the memory of oceans recorded in crystal, and hear the silence of time buried in volcanic seams, a quiet thought forms. If rocks remember by carrying scars, what other forms of memory might the earth hold, hidden in places where we have not yet learned to look? If rocks remember by carrying scars, then perhaps air remembers too, though in a very different way. Unlike stone, which holds tightly to its marks, the earliest atmosphere was restless, slipping and shifting, never remaining still. The air we breathe now seems permanent, even dependable, but that first breath of the planet was alien, unfamiliar, almost unrecognizable to us. It was not the calm blue sky we know. It was a thick, shrouded veil of gases, born of fire, shaped by eruptions, heavy with ingredients we would find unlivable. And yet, out of that strange, volatile haze, possibility was taking shape. Imagine standing on that early Earth if anyone could have. Looking upward, you would not see a steady blue, but a sky darkened by carbon dioxide, veiled in steam, perhaps tinged with hues of red or orange from volcanic particles scattered through the air. There would have been no oxygen to draw into your lungs, no fresh breeze to cool your face. Instead, the atmosphere was unpredictable, cycling storms across oceans that were only just beginning to settle. Lightning darted between clouds, striking seas that hissed with minerals and salt, the sound echoing across landscapes where no life yet stirred. This atmosphere was not yet hospitable, but like the oceans, it was dynamic, a ceaseless exchange of heat, energy, and chemistry, outgassed from molten rock, laced with methane, carbon dioxide, and nitrogen. It was both a veil and a crucible. We sometimes think of such air as toxic, but perhaps toxic is too narrow a word. It was not hostile because it meant harm. It was simply other, suited to a world not yet ready for us, but ready enough to begin shaping the foundation of what could come after. Isotopic evidence, locked in minerals and ancient rocks, tells us when oxygen began to appear, long after the Earth first formed. At first, there were only traces, oxygen released as a side effect of photochemical reactions in the upper atmosphere. Later, much more significant change came from cyanobacteria, breathing out oxygen as waste, transforming not only their environment but the fate of all life to come. But here, in these early chapters, oxygen was still a distant future, still only a promise carried inside chemical potential. The air of these youngest skies was almost suffocating, and yet, beneath its weight, the stage was already quietly being prepared. It is humbling to think of air as something with a history, a biography of its own. We fill our lungs without thinking, but once, there was nothing for lungs to hold. Once, the very idea of breathing was impossible. And even when oxygen arrived, it came not as gift but as disruption, a poison to many life forms that had survived in its absence. Could it be that every step forward requires some destruction too? Could it be that what feels necessary to us now once felt destructive to another world? When we picture the young atmosphere, we might see its tempests as chaotic, but maybe they were simply another rhythm, another kind of memory. Storms sweeping across oceans would not have been voices of violence, but of transformation, carrying gases downward, stirring chemicals into water, breaking molecules apart only to allow them to reform in startling new ways. Perhaps in those turbulent skies lightning forged new pathways, sparking reactions that rippled across seas, hinting toward the first fragile lifelines. Maybe the chaos was not chaos at all. Maybe it was creation wearing a mask of disorder. Entropy moved here as well, dispersing heat, carrying energy from one form into another, breaking patterns as quickly as they formed. Not because it sought destruction, but because this is the nature of time, always unfolding toward complexity and scattering. And in this scattering, in this blooming forward of chance, something subtle, something improbable, found a way to persist. A first chain of molecules that clung together longer than all the others, not because it was destined to, but simply because timing, pressure, and chemistry aligned in silence. The atmosphere, though turbulent, was never still. Even now, we can glimpse its early echoes preserved in trapped gases buried in ancient rock, in the chemistry of minerals, in the isotopic fingerprints that still linger like ghosts. These traces remind us that what we take as ordinary, the sky overhead, the air moving through the branches of trees, the simple act of inhaling, is anything but ordinary. It is the result of billions of years of balancing, shifting, and remembering. The present atmosphere is only the latest shape of something endlessly restless. Maybe the early air was thick and unbreathable, maybe it was suffocating and hostile, but in its unpredictability it carried the seeds of life. It suggests that discomfort is not the opposite of creation, but one of its essential precursors. And when we think about it that way, the uncertainty of those skies becomes less alien and more like a kind of preparation, a shaping, a rehearsal. And still we wonder what else might that atmosphere have held. What chemical pathways arose and disappeared, leaving no witness. What fleeting experiments in the architecture of molecules flashed, formed, and collapsed in the storms. The memory of that air is partial, erased, rewritten, buried beneath newer skies. But in the silence of its absence, we can still sense what it prepared for us. And if the first atmosphere could shape oceans and nurture the chemistry of beginnings, then what might fire and water have made together when their worlds touched? There were places on the young earth where molten rock did not rest quietly in the crust but rose, surged, and broke through, pouring streams of fire into the seas. Waves met magma in sudden chaos, steam rising with a roar, clouds of ash darkening already restless skies. To our eyes now it would appear violent, catastrophic, but perhaps to the planet itself it was less destruction than transformation, less ending than preparation. When fire met water, the newborn seas carried away the fragments of cooled lava, the minerals released from molten stone dissolving into brine. Each eruption became not just an act of release but a contribution to chemistry, a recipe written not in ink, but in ash and salt. Volcanic islands would have formed and sunk, over and over again, battered by tides too heavy for their fragile bodies to bear. Their ruins melted into the seafloor, scattered into particles, each one carrying with it new minerals that spread outward with the currents. Iron, magnesium, and silica drifted into solution. The water did not resist these gifts. It absorbed them, dissolved them, arranged them into subtle balances. We can hardly imagine it now, but those delicate shifts in chemistry may have been essential for the assembly of molecules, for life's earliest whispers. Scientists today study hydrothermal vents, where superheated fluids pour from cracks in the Earth's crust, creating black smokes that drift upward in alien towers of mineral. These places are alive now, teeming with strange creatures, yet long before that, such venting was already carving pathways of possibility. In the same way that rivers sculpt a valley, heat sculpted solutions within the water, setting up gradients that could do work, driving reactions forward. Perhaps fire and water together played the role of architect, combining destruction with balance, creating the scaffolds where molecules could linger long enough to form patterns too complex to vanish immediately. It is easy for us to imagine life as something separate from fire, something opposed to heat. But without fire, without this endless energy, the still chemistry of oceans might never have stirred. Fire, in its raw strength, broke bonds. Fire opened pathways. Fire added unpredictability into the smooth patience of water. Could it be that, without flame, memory would never have taken root? Could it be that the volatility of eruption was as necessary as the patience of the sea? And yet, fire was also forgetfulness. Entire landscapes, formed from earlier eruptions, would have been erased in an instant, remade under waves of fresh lava. In geology, this is constant. The planet remakes itself by consuming its own skin. Ocean floors are recycled in deep trenches, dragged downward into the mantle, melted, and returned later as mountains or islands. What we hope to trace from the beginning of time is often already rewritten. The evidence is erased almost as soon as it is made. For every mineral trace that survives, there are thousands destroyed in the churning cycle of heat and pressure. Fire not only creates, it erases. Not only births, it unburies. But maybe this cycle of erasure is the true condition of beginnings. Maybe nothing that lasts does so without having first survived loss. A molecule persisting against entropy, a mountain outlasting storms, a fragile pattern finding repetition. The same is true at every scale, from the sweep of geological ages to the delicate curve of a protein folding itself into order. Fire teaches that impermanence is not the opposite of memory but part of it. The scar and the erasure together form the story. Imagine the color of those early seas, stained not with algae or plankton as they are today, but with dissolved metal infused by volcanic eruptions. Imagine breathing the steam, if breath had been possible, and tasting the burn of sulfur and salt. In that haze, beneath the boiling water and the cooling glassy rocks, the first steps toward metabolism may have taken place. Fluids rising from vents carried energy in gradients, heat against cold, acid against alkaline. These differences are what life would one day exploit, pulling meaning out of imbalance, learning how to persist by moving energy across membranes of its own making. Without these contrasts, there is no life, only stillness. Perhaps the first cells were less like independent beings and more like extensions of the planet's own breath, the way water and fire exhaled into one another, binding, shattering, combining again and again, until something clung long enough not to disintegrate. Perhaps, seen in this way, life does not begin as a single spark but as a chorus of attempts, rising out of the contact between hot rock and cool sea. We will never know how many versions failed before one survived. Countless chemical civilizations, if we can call them that, must have risen and dissolved, built momentary scaffolds of memory that entropy dismantled before they could become more. Yet those forgotten attempts are also part of the story. Without them, perhaps no path would have been cleared for survival. Like erased pages beneath a manuscript, they are hidden but still necessary, their absence reminding us that failure, too, is part of creation. And so, in the mingling of fire and water, we see not only destruction but improbable patience. The earth, restless and burning, dissolved itself into possibility. Out of lava's violence came chemistry's subtlety. Out of boiling seas came the potential for inheritance. And if such creation can live within the encounter of flame and tide, then what else might time itself be hiding in the patience of its shadows? Before clocks, before calendars, before the rising and setting of the sun could ever be counted by eyes that noticed, there were still rhythms, silent markers traced not in thought but in atoms. Time was not yet something perceived. It was only something unfolding, and matter itself whispered its passing. Within the chemistry of rocks, Within the heart of elements, within isotopes born from ancient stars, there were quiet clocks, steady, reliable, yet unseen. In these first ages of the Earth, when no creature existed to measure, time measured itself. Every isotope is a fragment of memory, not in words but in decay rates, in the slow shedding of neutrons, in the invisible transformation of atoms into other forms. Uranium fading into lead, potassium softening into argon. These transitions are too slow for the human mind to sense. Yet across billions of years they become like heartbeats, rare, stretched, but as inevitable as the tide returning. By studying them now, we reach backward into eras where no story was kept, finding markers of cooling seas, of forming crust, of magma oceans solidifying into continents fragile but new. Time is recorded atom by atom, the Earth's earliest handwriting, carried in silence, never wiped away. If we think of fossils as the history of life, then isotopes are the fossils of time itself. They are the unblinking witnesses of change, embedded not in shapes of bone but in the chemistry carved into zircon, basalt, or shale. When scientists crush these minerals, searching for tiny gas bubbles preserved inside, what they find are not just numbers, but ages, a way to tell how old, how ancient, how profoundly deep these layers of memory go. Could it be that time itself is not something we create, but something matter has always carried, waiting for us to recognize it? Could it be that the clocks we build are only imitations of what already beats deep within every stone and element? Imagine a young Earth when the oceans first steamed and cooled. No one counted the centuries it took for the heat to fade into balance. No one marked the turning of a world that spun slightly faster, its days shorter than now. But isotopes marked it quietly, their ratios shifting in silence. They did not need witnesses. They did not need perception. Time was moving whether it was seen or not, indifferent yet meticulous, erasing and layering all at once. In this way, time was both presence and absence. It created memory by leaving signatures, but it also ensured forgetting. For every isotope that tells us of an ancient sea, there are countless rocks melted, countless records erased by subduction, swallowed into the mantle where pressure and heat stripped their stories clean. In deep time, remembrance is always paired with loss. We glimpse only fragments. An isotope trail in a crystal from Greenland, a strange oxygen ratio in zircon buried in Australia. But beyond what remains, the majority dissolves back into shadow, erased by the restless nature of the Earth itself. Perhaps this is why time feels so elusive. We try to hold it with calendars and hours, but the deeper we look, the more complicated it becomes. The oldest rocks tell us life began over 3.5 billion years ago, but the isotopic record hints even deeper, suggesting liquid water existed almost a billion years earlier than that. What does it mean for oceans to have waited so long before molecules crossed the threshold toward inheritance? How many beginnings were attempted, erased, and forgotten before one finally lasted? And yet, there is something almost soothing in this forgetting. If everything were preserved, the record would be overwhelming, unreadable, impossible to carry. Instead, time erases as much as it remembers, as though memory itself must be shaped by absence. Maybe this is true not only for the planet but for ourselves. We forget far more than we remember, and yet without forgetting, memory would lose its shape. Could it be that the silences of time are just as important as its voices? When we look at isotopes today under the careful calibration of instruments, we are not conjuring time out of nothing. We are only deciphering what matter has held all along. Their ratios mark the cooling of oceans, the emergence of atmosphere, the temperature of ancient climates, the very thermodynamics of a planet learning to inhabit itself. Stable yet transforming, constant yet restless, isotopes are like the planet's innermost pulse. To think of atoms as holding clocks raises an unsettling but gentle wonder. Does everything remember, in its own way? Does every grain, every molecule, carry the hint of what it once was? If so, then memory does not belong only to living beings but to everything, from the air we breathe to the rock beneath us. Not memory as thought, but memory as trace. Not memory as story, but memory as presence. And so we live suspended in time's shadow, walking across surfaces that carry hidden ages. When we gaze upon a cliff face streaked with bands of color, we are not merely seeing erosion. We are seeing isotopes recording the invisible. And when we think of our own lifetimes, brief and delicate, we can realize that we too are isotopes, transformations in motion, tiny flickers within a deeper clock. And if time itself is written into stone and sea, ticking patiently through isotopes that never needed eyes to see them, then what other energies might have carved themselves into the darkness long before life began to notice? Above those primeval oceans, the young skies were restless. Storms gathered thick in the air, towering clouds swelling with vapor, sparks of static building silently until they released as sudden, blinding threads. Lightning split the horizon in unpredictable bursts, striking the black waters with light so brief it was gone before it could be imagined. And yet, its aftereffects remained. A single bolt carried more energy than any wave could hold, disassembling molecules instantly, scattering atoms into new arrangements. The ocean beneath became both recipient and witness, stirred by chains of energy too fleeting to repeat the same way again. The scientists of our age call this process Miller-Urey chemistry, a phrase that folds an experiment into the vastness of geologic time. In a lab, sparks were sent through vessels filled with gases thought to resemble those early atmospheres: methane, hydrogen, ammonia, water vapor, and within days, amino acids had formed, the very building blocks of protein. If this can happen in the glass of a laboratory jar within days, then what might billions of years of lightning across billions of storms have written into the seas? The Earth itself was the longest-running experiment, its atmosphere the flask, its oceans the solvent, its storms the catalyst. But perhaps you notice something curious in this picture. Lightning is not steady, not patient, not ordered. It does not whisper, it shouts and vanishes. Could it be that the events which shaped life's beginnings did not emerge from calm but from interruptions, from noise, from sudden discharges of energy breaking silence? Maybe the irregularity itself was the gift. Maybe without chaos, no order could have ever stabilized. Not because lightning was designed to create, but because unpredictability cracked possibilities open where stillness alone could not. Imagine the sheer number of flashes across those early centuries. Not hundreds, not thousands, but uncountable storms rolling one into the next, filling the night with light that no eye would see. Each strike carrying its own accident, its own moment of rearrangement. Molecules clashed, reformed, dissolved. Most patterns ended there in dissolution, but a few lingered, surviving just long enough to be touched by another burst, another reaction, another chance. Slowly, across unimaginable spans, accident began to resemble persistence. And persistence is the seed of memory. It may feel strange to think of lightning as the ancestor of memory. After all, memory to us is quiet, something internal, almost delicate. Yet in those early oceans, memory of chemistry meant only this: a molecule that could copy itself, leaving a trace not just once but again and again. Lightning's role was not to conjure life directly but to flood oceans with raw material, ingredients restless enough to assemble and rearrange. Some would vanish, destroyed by entropy. Others would remain, faint scaffolds of structure awaiting their chance at continuity. Even now, lightning writes itself into the fabric of the world in ways we hardly notice. In a flash, it fixes nitrogen from the sky, binding it into forms that become nutrients for soil and plants. Energy marks the earth invisibly every day, reminding us that the line between destruction and creation is not as sharp as we sometimes believe. In deep time, perhaps all creation is born through disruption, through the sudden interruption of silence. Lightning was not just a strike. It was a rehearsal, a countless repetition of opportunities, most lost, some carried forward. If oceans held patience, and rocks carried scars, then lightning gave unpredictability. It offered chance, the irregularity needed for possibility to escape stillness. Could it be that life itself is less a destination and more a dialogue between patience and chaos, between the steady clock of isotopes and the wild noise of storms? Could it be that even now, in the unfolding of our brief moments, The pattern of order emerging from interruptions continues to shape us in ways we cannot see. The sky was not gentle then. Clouds towered with pressure, thick with gases we would find poison now. Lightning surged in chains across whole horizons. To imagine those nights, before breath, before witness, is to imagine the planet glowing intermittently with fire from within and sparks from above. Its oceans simmering with chemistry, its air electrified with restlessness. A laboratory without design, yet filled with possibility. Maybe most of what lightning sparked dissolved back into silence. Maybe its role was less to create than to unsettle, to open doors and immediately close them again, leaving behind only a trace of passage. But among those doors, enough stayed open long enough for chemistry to walk through, long enough for atoms to find new alignments, long enough for energy to see geometry. And if unseen storms could electrify oceans into possibility, then what might quieter surfaces, minerals in still landscapes, clays resting patient beneath waters, have hidden in their lattices, waiting to shape chemistry in their own silent way? Unlike lightning, which arrives in sudden flashes, minerals are steady, almost eternal in their waiting. They do not shout, they hold. Crystals, clays, and mineral grains spread across early shorelines and beneath shallow waters, their surfaces silently inviting molecules to gather and linger. In these places, motion slowed. Instead of dispersing in the endless wash of ocean currents, fragile combinations of atoms could find refuge, attaching to the tiny ridges and grooves of mineral scaffolds. It was this stillness, this patience, that offered chemistry a chance not simply to form, but to linger long enough to remember itself. Clay, layered in sheets so fine they slip against each other like pages, may have been the first silent library of molecules. Its flat surfaces and charged edges drew fragments of chemical chains to align side by side. Here they could repeat, then repeat again, creating patterns that might one day teach the meaning of replication. The gaps between mineral layers acted not only as walls but as whispers, reminding stray molecules to stay together when the ocean around them wished to scatter them apart. Could it be that the earth itself once practiced language through stone, speaking not in words but in arrangements, in repeating forms that hinted toward inheritance? Crystals too may have played their part. In the lattice of their ordered atoms, new compounds found themselves nudged into structure, guided by the rhythm of geometry. It's easy to forget how much of the natural world depends on repetition. Patterns repeating until form arises. Snowflakes, shells, even the spiraling galaxy, the lesson of order is everywhere. Perhaps the first lesson was written in minerals, long before life drew breath to speak it out loud. And yet, there is a paradox here. Minerals are static, enduring, seemingly eternal. Chemistry is restless, wanting to dissolve, recombine, scatter. Their meeting was a dialogue between permanence and impermanence, between structure and fluidity. Could it be that life itself owes its existence to this balance? That without stone's patience, water's chaos would never have given rise to lasting form? We often imagine beginnings as sparks, as dramatic bursts of sudden creation. But what if beginnings are instead as slow as clay drying, as crystals layering themselves grain by grain? What if life's earliest steps were quiet acts of patience, not explosions of possibility but accumulations of pattern? Maybe, maybe not. But the suggestion carries something humbling, the idea that time itself was the true architect, and minerals were simply its canvas. Scientists call this hypothesis the clay template theory, suggesting that RNA, the molecule that once carried memory before DNA refined it, may have first assembled upon mineral layers. The surfaces of stone acted as teacher, guiding molecules into alignment until, eventually, they could guide themselves. It is not difficult to imagine. The earth itself was vast, its shorelines endless, its minerals plentiful. There would have been uncountable opportunities for these microscopic rehearsals, chances repeated endlessly until, finally, one succeeded in persisting. But here too lies the shadow of forgetting. For every molecule that learned to organize, countless more collapsed back into entropy, dissolved by water, burned by ultraviolet rays, or broken apart by chance collisions. The patience of minerals allowed for memory to arise, but it did not prevent forgetting. Only the rarest of arrangements could endure long enough to be carried forward, and we, billions of years later, are descendants of their persistence. Still, the silence of stone keeps most secrets erased. We can imagine it, but we cannot recover it fully. The true story of clay and crystal remains hidden, as all first drafts of creation eventually do. And yet there is something deeply poetic about the thought that the earliest memory may not have been written on paper, or even in the encoded spiral of DNA, but instead in the spacing of surfaces, in the layered stillness of rock. That inheritance itself may have first taken root in places we walk over and barely notice, the humble patience of clay, the quiet certainty of crystals. Perhaps minerals are not only scaffolds of chemistry but scaffolds of thought. To look at a rock, ordinary and unadorned, is to see a remnant of a language the planet once used, a script older than imagination. And when we try to perceive what life's first words might have been, it may not have been sound at all. It may have been arrangement, repetition, bond, and break. A kind of grammar carved into clay's thin sheets, into the invisible lattice of mineral form. And so the question lingers, if stone could offer the stage for molecules to organize, then what role did darkness itself play? In the places where sunlight never reached, where the deep vents of the earth exhaled their heat and minerals glowed unseen, could another beginning have been taking shape, one that did not lean on light or surface, but on the endless breadth of the planet's interior? Far beneath the surface, below the restless waves and beyond the reach of the first sunlit horizons, lies a realm of blackness. In this blackness, there were chasms splitting open along the newborn ocean floor, where molten rock met seawater, and the earth exhaled through them like a sleeping beast. Superheated fluids burst upward, heavy with metals, sulfides, and minerals, curling into columns of black smoke as they hit the icy depths around them. To our eyes, this seafloor would have seemed alien, as though another world entirely. Yet to chemistry it was more than alien, it was fertile. At these hydrothermal vents, the recipe for creation was written not by the hand of light, but by the mingling of opposites. Hot and cold, acidic and alkaline, mineral and molecule. The differences created gradients, and gradients are opportunity. They are imbalance waiting to be resolved. And perhaps, in seeking resolution, molecules learn to capture energy, to fold into themselves the memory of imbalance, to turn it into motion, into persistence. Some scientists believe it may have been here, in this perpetual twilight, that the first true metabolism appeared, not as blood pumping or lungs breathing, but as chemistry finding a way to channel contrast into survival. These vents built cathedrals of stone in the dark, towers of minerals rising into water like underwater chimneys, porous with channels that trapped fluids, lined with surfaces that guided reactions. Within their cavities, molecules could have gathered the way early life might gather around shelter, hidden from the violent chaos of open seas, nurtured instead by gradients of heat and chemistry. Could it be that life's first shelter was built not from bone or shell, but from scaffolds of stone shaped by the breath of the planet itself? This possibility is humbling because it reframes life not as something separate from geology, but as an extension of it. The vent becomes parent as much as environment, its mineral pores like a protocell wall, its surfaces a substitute for membranes not yet imagined. Later, life would invent the cell. But perhaps before that, the earth itself played the role of container, of organelle, of body. Maybe what we call life began less as individual things and more as the planet itself gently folding chemistry inward, as though cupping fragile sparks to shield them from being extinguished. And all this unfolded in absolute darkness, in places no ray of sunlight ever touched. A dawn without light, a creation that leaned not on photosynthesis, not on the sky, but on the depths we often overlook. When we tell the story of life, we so often imagine light. Plants spreading leaves, animals crawling toward daybreak. But here was another story, one hidden in blackness, one written in minerals, a story where warmth came from the depths, not from the sky. Could it be that life still remembers this? That even now, every cell carries the faint reminder of a beginning without light, a metabolism born of stone and heat? And even if this is true, Or if it is only one of many beginnings, the question remains. How many other possible cradles of life were erased in silence? Hydrothermal vents vanish as tectonic plates shift and ocean floors are consumed. The earliest vents that may have incubated the first cells are long gone, subducted, melted, forgotten. For every vent that survives long enough to build a structure of mineral towers, countless others collapse without record. Our evidence is a shadow of what truly was, fragments studied today through mimicry in laboratories and through whispers in chemistry left behind. This uncertainty does not diminish the wonder, it deepens it. For perhaps creation was never meant to be singular. Perhaps it was an orchestra of attempts, trials unfolding in oceans, in clay, in lightning, in vents. Most failed. Some endured. All shaped the path forward. Do we imagine too narrowly when we ask for a single birthplace? Could it be instead that Earth experimented endlessly, in every environment it offered, until patterns strong enough to survive emerged from the chorus of attempts? When we look at vents today, alive with strange organisms, tube worms, bacteria, shrimp thriving without light, we are not just seeing ecosystems. We are seeing reminders. These organisms are not direct descendants of the very first spark, but perhaps cousins in spirit, echoes of the possibility that something could grow in darkness, nourished only by chemistry and heat. Perhaps they are living fossils not of creatures, but of concepts, reminders that life's beginnings may not have needed light at all. A dawn without sunlight is difficult for us to imagine because our perception of dawn is so deeply tied to brightness, to vision. Yet this dawn was no less real. It was dawn measured by chemistry, not by color. Dawn measured by persistence, not by appearance. A dawn carried not by light, but by structure. And if darkness could hold its own kind of dawn, then what of entropy, that quiet, inevitable drift toward disorder? Could even the pull of decay itself have written as much of life's beginning as the patterns that resisted it? Entropy is often described as destruction, as unraveling, as endings. But here, in the earliest ages of Earth, it was not an enemy. It was the background condition, the canvas stretched beneath every act of chemistry. Molecules dissolved because entropy asked them to. Bonds broke because entropy reminded them there was always another way to exist. If beginnings are fragile, it is because they stand against this pull. But without decay, there is no context for persistence, no space for order to reveal itself. Entropy is not the opposite of life. It is the very framework within which life must move. Every molecule that formed in those restless seas was destined to break apart. Proteins twisted into fragile folds, only to collapse moments later. Chains of nucleotides began to assemble, only to unwind into scattered fragments. Countless attempts vanished almost as quickly as they appeared. Yet, in the language of entropy, this was not failure, it was exploration. For every arrangement that dissolved, another had a chance to appear. For every pattern erased, another trial was invited. Could it be that the constant pressure of loss is what allowed creation to emerge at all? In this balance, life found its threshold. On one side waited silence, the ease of dissolution, the constant drift toward equilibrium where nothing maintains distinction. On the other side waited endurance, molecules discovering not just how to form but how to copy, how to repeat and return, carving tiny deferrals against loss. It is here, in that knife edge between persistence and forgetting, that life was born. Not because entropy created it, but because entropy refused to allow stasis. Even the simplest living chemistry was already a paradox, an act of resisting the pull toward disappearance by bending the rules of chance into repetition. The very first cells, if they can be called cells at all, were delicate containers of difference. Little selves made of membranes fragile enough to burst, yet strong enough to hold out against chaos long enough to learn continuity. Within them, molecules exchanged energy, passing electrons like whispers, turning imbalance into rhythm. To exist was to hold structure against collapse. To survive was to do so not once, but again and again. Life was a pause in the endless drift, a refusal to unravel, though always temporary, always precarious. And this is the quiet truth we glimpse when we step back. Life and entropy were never enemies. They were partners in dialogue. One pulled toward disorder, the other toward repetition, and somewhere in between, cycles arose: metabolism, replication, memory. Without entropy, life could not have learned persistence, because there would have been no resistance to push against. Without entropy, no chemistry would have ever been stirred to try again. Could it be, then, that life is not actually the conquest of order over chaos, but the embrace of both, their collaboration carved into every breath we take? Even now, billions of years later, our own cells carry this paradox. DNA holds memory, copying itself, yet every copy introduces chances of error. Proteins fold into exquisite forms, yet each will eventually fray and decay. Our existence is composed of countless little battles with entropy, battles we always lose in the end, but battles that allow life to exist at all in the meantime. Memory and forgetting coexist within us, just as they did in the first chemistry that clung to stone or drifted near vents. Entropy also ensures humility. Whatever was written in those first oceans, we will never know in full. The early scaffolds of life's chemistry have been erased, their fragile traces gone as though they never occurred. Only hints remain in the isotopic records. Only shadows linger in fragments of ancient rocks. If most of history is forgotten, then perhaps forgetting itself is also part of the story. Without it, we might never recognize the miracle of what endured. Perhaps memory is precious precisely because it is rare, carved out against the background of all that has already dissolved. And so we drift in this recognition, that for every living thing, forgetting is not failure but necessity. Without it, nothing new could begin. Entropy provides the silence into which creation sings, the erasure that allows memory to stand out. Life is not the absence of loss, it is persistence in spite of it. And if the first cells carried this paradox, then so do we, every moment, every breath, each heartbeat a deferral of silence, each thought a fragile resistance etched against the pull of forgetting. And yet, even fragile persistence leaves traces. If so much dissolves, what might remain hidden? The quiet shadows of lives or chemistries that formed, endured for a moment, and left no fossils, no evidence. If entropy erases with such patience, then what forgotten worlds may have slipped past us already? We tend to think of fossils as the anchor of the past, the places where the earth puts its stories into stone. A leaf pressed into shale, a skeleton mineralized into rock, a shell preserved in limestone, still spiraled after millions of years. Fossils reassure us that history can be touched, that memory can leave its shape behind. But in the earliest chapters of Earth, there were no such anchors. Before bones, before shells, before skeletons hardened into permanence, the world was filled with lives and patterns that left nothing to mark their presence. They arose, dissolved, and vanished back into water and heat with not even a shadow left to find. In those first oceans, cells may have multiplied in fragile bursts, communities forming like clouds of dust only to disperse. Entire lineages could have existed, tiny chains of molecules experimenting with survival, yet none of them survived long enough to inscribe themselves into geology. At temperatures too high, their forms would have been erased almost instantly. In seas that churned endlessly, their patterns would have been torn apart and scattered. In time pulled down into subduction, their elements would have been melted and lifted again as new crust, all record of those moments utterly gone. Could it be that whole forgotten epochs of life once swam and vanished before what we call the beginning even arrived? Could it be that Earth's earliest civilizations of chemistry left no fossils not because they never existed, but because their traces were erased too quickly? It is strange to wonder about these things, because our sense of history rests so heavily on evidence. We want to see fossils because they allow us to believe our stories are secure. But what happens when history itself cannot fossilize? What if the first 3 billion years of life were largely unwritten, carried forward only through absence? We call it the Precambrian, the hidden time, but perhaps hidden understates the depth of forgetting. Perhaps most of life has always belonged not to memory, but to silence. Even when fossilization became possible, it was never reliable. For something to fossilize requires coincidence, a near miracle of circumstances. a body buried quickly, far from scavengers, in sediments that can compress and preserve rather than scatter. Most lives, even much later in Earth's unfolding story, did not meet such conditions. The fossil record is a whisper, a partial archive built more from exception than from rule. If that is true for trilobites, for dinosaurs, for mammals, then imagine how much more silent the record is for the earliest forms, when nothing yet had armor or skeleton or bone. What they left behind was chemistry, not shape. And chemistry is harder to preserve, harder to recognize, easier to lose. The weight of this absence unsettles, but also invites humility. When we peer into ancient rocks and find traces of carbon isotopes, altered ratios that hint at metabolism billions of years ago, we are not seeing the lives themselves, we are seeing faint shadows like smoke after a fire already gone. They are not fossils in the way we imagine fossils, but they are enough to quietly suggest that something once breathed, once metabolized, once endured. Yet even these signals are contested. Maybe they are true traces of biology. Maybe they are simply chemical accidents that mimic life but never crossed its threshold. Maybe not. Absence, then, becomes part of the narrative. The fossils that never formed remind us that most of history is hidden, unreachable. And still, in that mystery, there is space. Space to wonder not just what lived, but how different it might have been from what we know. Were there forms of life that used molecules we no longer see, metabolisms entirely erased? Did they vanish because they were too fragile, or because something better replaced them? Or did they survive but left no record we know how to read? When we imagine the fossil record, we must learn to imagine its missingness too. Perhaps the silence is as important as the evidence. And this silence is not unique to the deep past. Even now, if time were to fast forward 10 million years, what story would be found in our present? Would our bones fossilize? Would our structures endure? Or would the vast majority of what we are collapse into the same erasure that has always claimed history? Maybe fossils are not promises at all. They are rare exceptions, windows so narrow that to mistake them for the whole story is to forget how much lies beyond their frame. If the earliest worlds left no fossils, then we live surrounded not by absence, but by erasure. To hold a stone from 4 billion years ago is to hold silence, to hold memory already lost before memory began. And yet, if this much can vanish, if so much is gone without imprint, then what might exist in the history between emergences? What possibility might hide in the extinctions that came before life even learned to endure? When we speak of extinction, we usually mean the loss of whole species. Dinosaurs erased by an asteroid, trilobites swallowed by shifting oceans, mammoths fading into the slow hunger of ice. But before there were creatures to lose, before bones lined the past, there were extinctions of another kind. Chemical extinctions, erasures so profound and silent that no one remembers because no one was there to witness them. Not the loss of skeletons, but the loss of possibilities. Not the death of body, but the dissolving of fragile chains that might have become life, if only they had endured a little longer. Imagine oceans filled with unfinished attempts, proteins folding only to collapse back into nothing, nucleotides joining only to break apart in the next wave, structures half-formed dissolving into their components, swept away into silence. Entire chemical civilizations may have risen and fallen in seconds, erased before even the concept of continuity existed. Could it be that life's story is less about one triumphant beginning, and more about an infinite series of failures, billions upon billions of tiny extinctions, each one forgotten the moment it dissolved? Entropy was the sculptor of this forgetting, always nudging matter back toward simplicity, toward dispersal. Heat scattered molecules. Ultraviolet light from the young sun burned away delicate strands. The pull of chemistry itself unmade what had only just been made. And yet, in this endless erasure, experiments continued. Each failure was not truly an end, but another reshuffling of matter, another attempt waiting in silence. Maybe extinction and creation were not separate at all, but twins bound together, each giving meaning to the other. It was only within this dialogue of becoming and unraveling that life could finally emerge. There are theories that whole alternate metabolisms may have flickered into existence and disappeared just as quickly. Life that breathed molecules we no longer recognize. Life that fed on chemistries erased entirely from the modern planet. We cannot prove it, but absence itself invites the question. What if the Earth bore many childhoods of life, only one of which survived into memory? What if we, our DNA, our cells, our stories, are only the latest inheritance of one lucky lineage, while countless others have been erased without trace? When we look to the rocks, they do not remember these extinctions. Heat has recycled their testimony. Pressure has erased what they might have preserved. All that remains are the silences between isotopes, the unanswered spaces where presence was once suggested. And yet, perhaps forgetting is part of the balance. For without silence, there would be no room for memory. Without extinction, there would be no survival. Could it be that creation only exists in relation to what is lost? That life's endurance acquires its wonder from the shadow constantly surrounding it? It is humbling to imagine that extinction existed even before life. To think of silence not as aftermath but as origin. To consider that destruction and erasure do not follow creation, but accompany it from the very start. This takes us away from the comforting story of a single spark, a singular birth of life, and draws us towards something messier but more intimate. A world always experimenting, always erasing, always balancing silence and possibility. Perhaps this is why life carries fragility within it even now. Cells divide, but they also fail. DNA copies, but it also mutates and dissolves. Everything living is touched by extinction, because extinction is not an accident. It is part of the law written into existence. It was here before life and will accompany it long after. Extinction is not the end of life's story. It is interwoven with it, inseparable. And yet, even in silence, traces of possibility remain. When we look at hydrothermal vents or examine patterns in minerals, we glimpse not only what survived, but the memory of everything that did not. Failed experiments, collapsed chemistries, abandoned paths, they live in absence, but absence too speaks. Maybe the fossils that never formed are fossils of a kind, the shape of silence itself, the pattern of what could not stay. So when we hold a rock from deep time, we are not only touching what persisted. We are also touching what was erased, what never left shape but still belongs to the story. Life came from this tension, from this constant entwining of becoming and dissolving. And even as we search for signs in isotopes and sediments, perhaps what we are truly searching for is not the evidence of how life began, but the acceptance that it began within silence, alongside endings that left no trace. And if the planet rehearsed countless beginnings before one succeeded, if these extinctions of chemistry were as real as any future extinction of species, then we must ask gently, what else has been lost within the silence? What chapters of Earth's story have been erased so fully that we will never know they were written? Even what did endure was shaped not by stillness but by cycles. The Earth has never been steady for long. It breathes in great rhythms of heat and cold, wetness and dryness, oxygen and suffocation. From its youngest ages, climate shifted in pulses, drawn by eruptions, by tilts in its orbit, by chemical balances tipping across atmosphere and sea. Life's cradle was never built upon calm stability, but upon oscillations so extreme that oceans themselves froze to their beds and, in other ages, boiled into haze beneath a heavy sky. We call them snowball Earth moments, those times when ice stretched from pole to equator, wrapping the planet in reflective silence. So much light bounced back into space that the seas threatened to remain locked beneath an icy shell. If you could have drifted above our world then, you would not have seen the blue planet we know. You would have seen a white one, glittering and still, a frozen marble turning in shadow. And yet, even beneath miles of ice, vents still released heat, salty brine still carried minerals, and life, fragile though it was, may have endured in pockets of persistence, cradled by warmth rising through darkness. And then the pendulum swung the other way. Volcanic gases filled the sky, carbon dioxide thickening the air until the freeze collapsed into heat. Greenhouse warmth surged unchecked, and whole seas may have boiled at the surface, releasing steam into skies already choked with haze. Imagine standing on the planet in such an age. The air heavy, the waters fuming, the horizon drowned in storms. Not endings and beginnings, not failures and triumphs, but pulses, back and forth, cold and heat shaping what could survive. Even the most ancient surviving rocks reveal these shifts in hidden chemistry. Traces of isotopes that point to freezing times and overheated epochs, signatures of carbon cycling wildly, oxygen rising then falling, each peak and trough exchanging one form of possibility for another. Could it be that life itself was not only seated in these rhythms, but sculpted by them, that its patience was trained in the context of instability? It is humbling to realize that balance has never been the natural state of Earth. What we call balance is only the space between oscillations, the pause in a pendulum forever in motion. And life seems always to have been born and tested within these spaces. In frozen oceans, persistence was taught through endurance. In boiling seas, survival was taught through resilience. Perhaps even us, billions of years later, still carry this ancestral memory within our cells. The deep knowledge that all stability is temporary, that survival comes through flexibility in the face of cycles older than breath itself. And yet, while these cycles are written in stone and isotope, they remain distant for us, almost dreamlike. We count our lives in decades, maybe centuries if we stretch across memory of ancestors. Earth counts in millions. Ice comes, then retreats only to return. Seas rise and fall until their shorelines are erased and rewritten. What could feel like an endless world to us is to the planet a fleeting mood, a brief balancing before the next turn. Could it be that Earth itself is always restless, always oscillating, and that life is less a defiance of this restlessness than a child of it? When we breathe, we mimic the same motion in miniature, in and out, expanding and contracting. Breath is just another cycle, a life bound between pauses, an echo of the same rhythm that froze oceans and boiled seas. Maybe this is why the rise and fall of climate across deep time feels almost musical when described in isotope records. Not because the Earth intends melody, but because pattern itself emerges when energy moves back and forth, never still. The earliest cells rested in this restless cradle, riding the rise and fall like driftwood caught in tides too vast to comprehend. They did not choose each world they inherited, whether frozen or boiling, but they adapted. Those that could not were erased, their memory folded back into silence. Those that learned the rhythm became our ancestors. The ones that bent, endured. The ones that resisted, dissolved. Perhaps life itself has always been less about conquering and more about learning how to sway with the pendulum, how to fold instability into persistence. And if oceans could freeze solid and later rise to steam, if the very environments of survival could reverse so utterly across ages, then we are left with another question to carry us forward. If climates could change so violently in the absence of life, what might happen to them once life itself began to breathe back into the sky, altering the air with every molecule it exhaled? Perhaps the answer lies not only within the Earth but also in what drifted from beyond, dust carried not by tides or winds, but by the greater universe itself. For long before our planet was covered in forests, before oceans filled with creatures, before even the first cell remembered to divide, the Earth was receiving messages from the stars. Grains of dust floated across the void, relics of ancient explosions, fragments from suns that died long before ours was born. Each speck was unimaginably small, and yet each carried with it the memory of fusion, the signature of starfire. They settled quietly, falling through an atmosphere that thickened like a veil, drifting into seas that were already stirring with restless chemistry. In this way, the Earth was never alone. It was never sealed within itself. It was always open to what the wider cosmos delivered. These grains, composed of carbon, iron, magnesium, and countless other trace elements, joined with what the planet was already making, seeding layers of possibility that were not born here but inherited from stellar ancestors. Could it be that within every cell alive today, there is not just the imprint of oceans or vents or minerals, but of stars themselves, the echo of cosmic dust wrapped into our very beginnings? The thought is humbling. We often imagine life as a terrestrial event, as though Earth invented it entirely from its own resources. But when we study isotopes scattered in ancient sediments, when we measure the rare ratios of certain elements, we find signatures that are not born of Earth's geology at all. They are interstellar in nature, etched in atom by atom long before this planet even solidified. Supernovae left us with heavy metals. Dying stars left us with carbon. Silent drifting carried the grains across light years until gravity and atmosphere pulled them down. Perhaps every storm that sparked new molecules in those fledgling seas also carried echoes of stars that exploded billions of years away. There is a gentle beauty in thinking that the beginnings of life were never singular, never purely local. Earth's story was already cosmic. Every molecule that aligned, every chain that formed and lasted, did so partly because the building blocks had been delivered across unimaginable expanses. This truth means that creation was not a solitary event, not a closed loop, but a continuation, a handing down of material, a gift from systems older and grander than we can fully hold in thought. Maybe this is why memory feels so vast, why silence feels so full of possibility, because even in the smallest fragment, we carry a lineage that begins in stars no eye has ever seen. And yet, as with all stories of origin, there is erasure too. For every particle that settled into the ocean, countless others disintegrated in the atmosphere, or were buried in lava, or lost in tectonic churn. The silence of extinction before life was mirrored here, too, in the anonymity of dust lost without witness. Still, enough remained. Enough to work its way into rocks, into oceans, into the chemistry that, by patience and chance, began to remember itself. Perhaps if we let the idea settle, it begins to feel inevitable. That life would not merely be Earth's response to geology and climate, but also an echo of something older, something universal. Dust carrying potential not extinguished in death but recycled in new beginnings. The atoms of our bodies, the calcium in our bones, the oxygen in every breath, the iron in every pulse of blood. All were once inside stars that burned, collapsed, and scattered. We are not only Earth's children, we are the children of supernovae. Could it be that life everywhere, on any world, is always this, an echo of cosmic dust taking temporary form before silence takes it back? The earliest seas did not know the poetry of this inheritance. They absorbed dust without meaning. And yet, within them, a fusion of geology, atmosphere, and stardust created conditions we still try to imagine. Minerals catalyzing, molecules joining, lightning sparking possibilities. And when replication finally lingered, when the first chain of memory began to copy itself, something more than Earth spoke through that act. It was the cosmos itself, carrying its echo forward. And if the universe can send its fragments across light years into the depths of oceans, then what else might Earth's waters have carried in their subtle patience? What quiet memory could water hold on its own? At first glance, water feels like the most ordinary thing. We drink it, we bathe in it, we hear it falling from clouds. But the truth is that water has always been more than reflection. It carries structure, flow, erosion, and countless repetitions that shape almost everything we know. The oceans, the rivers, the rain are not only surfaces we see. They are patterns unfolding, reshaping, remembering. Even before there was life to name them, water was already the planet's oldest stage, repeating its ceaseless circulation. Water remembers not by keeping images like our minds, but by movement and transformation. A drop that falls on rock carries minerals with it, whereas the surface smoother, carves a microscopic groove that will guide the next drop. Over years, that groove deepens into a channel. Over millennia, it becomes a valley. And over eons, whole landscapes are sculpted by nothing more than liquid persistence. Could it be that this slow carving is memory too? Not memory in thought, but memory in form. Land and sea holding the shape of what water has touched. In deep time, water does not rest. It circulates between ocean and sky, between ice and vapor, between stone and subterranean depths. Every molecule journeys endlessly, shifting phases but never truly disappearing. Geologists call this the hydrologic cycle, but perhaps it is more like the Earth's own breath. Inhales of condensation, exhales of evaporation, storms rising, rivers falling, glaciers advancing, tides retreating, all part of a respiration older than lungs, older than sound, older even than the first stirrings of life. Even the chemistry of beginnings depended on this restlessness. Water dissolved minerals from volcanic rock, carried them into oceans, concentrated them in tidal pools. It mixed what was separate and separated what was mingled, spreading patterns across the globe that no single event could have created alone. Lightning needed water as canvas. Clays needed water to carry molecules between their layers. Hydrothermal vents needed water as mediator, channeling heat and minerals into pockets of fertility. All the varied experiments of chemistry occurred because water flowed, pulled, redistributed. Persistence came not from stillness, but from motion. And water's role was not only external. Inside the first cells, water was the medium of life itself, filling the tiny spaces within membranes, carrying ions, carrying nutrients, allowing order to balance delicately against entropy. Even today, our blood is mostly water. Our breath condenses into vapor. Our tears carry salt from seas that remember origins. To ask where life began is almost the same as asking what water is, how it holds both fragility and permanence at once. There is also something quietly spiritual in thinking of water's endurance. The same molecules that once bathed early Earth linger still. The rain that falls on us may once have condensed on the surface of a molten ocean. The sip we take from a spring may hold molecules forged in comets, drifting from interstellar ice long before we were here. Could it be that water is not only the stage of possibility, but its archivist as well, carrying whispers of all it has touched from deep time into our present moment? But water, like all forms of memory, is not perfect. It erases even as it preserves. Floods wipe away landscapes as quickly as they carve them. Glaciers grind mountains into silence. Rivers dissolve their own banks and carry the fragments to seas, where tides scatter them into anonymity. Memory is always partnered with loss. Yet loss is part of water's nature, part of what gives it power. Not solidity, but flow, not permanence, but momentum. What exists now exists because water has already forgotten countless shapes before. Maybe memory is not about holding on, but about carrying forward. Always moving, always reshaping, always passing the story along. The earliest cells could not have survived without this patience. They needed both the stillness of a tide pool and the chaos of a wave, both the dissolving of minerals and the distribution of nutrients. They were as bound to water as we are today, not because they chose to be, but because water is where inheritance itself first learned to continue. Compared to stars or stone, life is fragile. But in water, fragility finds momentum, continuity across time scales too long for us to hold. And if water is memory, then it is also question. What else might oceans have recorded that we cannot decipher? What forgotten chemistries did they hold before cells stabilized their inheritance? How many beginnings dissolved silently into the tide, erased as completely as fossils that never formed? Perhaps water does not speak in fossils at all. Perhaps it speaks only in flow, hinting at everything it has carried but never holding it still for us to read. And if water could become both archivist and eraser, if it could shape the earliest steps of life and still veil so much in silence, then what might the restless geology beneath it have remembered, reshaping memory under mountains and tectonic drift? For while oceans flowed and cycled, the solid earth below was never still. Geology itself was witness to beginnings, but its witness was restless, complicated, always rewriting the record it sought to keep. From shifting tectonic plates to volcanic arcs, from rising mountains to the grinding down of valleys, the Earth was constantly reshaping itself beneath the first fragile chemistry that clung to its surface. Even before there were forests or bodies to fossilize, tectonic drift began erasing. The crust folded back on itself, subducted into the mantle, melted to magma, cooled again into new stone. Layers upon layers were built, but so often the oldest layers were consumed, leaving only fragments as testimony. If rocks hold scars, we must remember the scars do not stay. Over millions of years, they are hidden beneath newer skins of sediment, buried until they no longer speak of beginnings but of middles. The surface of the earth is never an archive in the sense of permanence. It is instead a palimpsest, a manuscript endlessly rewritten, its earlier inscriptions scraped away, overlaid with new text, new marks, new movements. What was lost is often greater than what remains. And yet, even in this erasure, hints persist, traces folded deep in the crust, isotopes trapped within zircon crystals, iron bands whispering of oxygen cycles that surged and dropped again long before breath was possible. This is perhaps the paradox of geology. It records by erasing. A mountain that rises does so only because of subduction driving one plate beneath another, an act that swallows entire regions of seafloor, including their memories. Volcanoes speak of deep interior processes, but in erupting they cover older lands beneath thick flows of basalt, a burial as much as creation. Earthquakes crack apart the crust, shifting it violently, but also opening new spaces where minerals drip into veins that later tell stories of chemistry, now long removed from the surface. Could it be that remembrance at planetary scale is always bound to transformation? Could it be that without destruction, even traces of creation might never emerge? We feel mountains as immovable, but to the planet they are ephemeral. The Himalayas, still rising today, are a mere scratch in the timescales of Earth. To future ages, they will erode into silt and sediment, redistributing their height into lakes and seas. Already, the worn faces of older ranges remind us of this truth. The Appalachians were once as towering as Everest, yet they are soft ridges now, worn almost to the root. Still, their stones carry mineral ratios that whisper of colliding continents, supercontinents forming and breaking apart long before we existed. This is geology's way of remembering, not by preserving shapes forever, but by embedding chemical signals, textures, and pressures into places no eye could read until now. Even silence has its signals. There are times in the Earth's ancient record where no rocks remain for entire spans of hundreds of millions of years. These are called unconformities, gaps where erosion stripped everything away before new material was laid down. A canyon wall may show layers stacked neatly, each telling of time's passage, but cut into that wall is often an absence, a missing slice of history. Where did it go? Was it melted inward? Carried away by rivers? Lost altogether? What is striking is that these gaps can be longer than all of human history many times over. They remind us that most of Earth's story is not what we see, but what is gone. And yet, even with all this erasure, geology whispers enough for us to lean in closer. Isotopes remind us of vanished seas. Folded strata tell us of ancient collisions. Sediments trace the retreat of glaciers that came and went long before names. The Earth does not hold on to detail in ways we might wish, but it carries essence, broad strokes across incomprehensible ages. Still, when we see those folded layers, when we stand in a canyon's silence, we feel something more than science alone. We feel the presence of memory, not human memory, but a planetary one, abstract, partial, fragmentary, and yet undeniable. Perhaps this is why landscapes calm us. To gaze upon a mountain is to feel the pressure of ages quietly present in its form. To walk across desert stone is to walk upon rock that has been both seafloor and dune, both buried and uncovered, both erased and rewritten countless times. These forms are restless witnesses. They are not storytellers in the way we understand stories, but in their scars and silences, they tell of deep time, of persistence bound to transformation. Maybe this is why they move us into stillness, because what we sense is the immensity of memory far outside our own scale. And yet, if all this is already written into stone, then what happens to the atmosphere above, to the air that is not as permanent but equally touched by the weight of memory? What do the gases themselves recall of their ceaseless transformations across these forgotten cycles? Perhaps the answer waits somewhere smaller, quieter, softer, within the most fragile beginnings of life that dared to hold form at all. In the restless oceans, with minerals dissolving and gradients forming, chemistry unfolded into something astonishing. Tiny boundaries began to appear, thin bubbles that trapped molecules inside, membranes delicate enough to rupture at a touch, but strong enough to grant a momentary separation between inside and out. These were not yet cells in the way we know them, not yet beings with certainty, but they were protocells, the first fragile shells against chaos. And in them, for the first time, there was a whisper of distinction. a boundary that could be called self. To us, the word self carries weight, heavy with memory and identity. We imagine thought, reflection, choice. But here, self was something far simpler, and perhaps more profound. The tiniest droplet of molecules enclosed against the tide, maintaining order within, clinging to persistence for just a little longer than the ocean otherwise permitted. Maybe not alive in the way we define it today, but already rehearsing the dream of life. Could it be that the earliest cells did not begin as beings at all, but as shelters, small places where chemistry lingered long enough to begin remembering itself? These membranes, often imagined as fatty molecules aligning into spheres, formed spontaneously in water. They were accidents, but accidents repeated so often they ceased to be rare. Within their boundaries, chemical reactions became enclosed, protected from the vast dilution of the sea. In that containment, conditions grew different inside from outside. And once there is difference, there is possibility. Energy can be exchanged, gradients can be built, memory can begin to take shape. Protocell does not think, but it persists. And to persist is to carry the faint echo of memory forward. Perhaps we underestimate what this meant. For billions of years, matter had moved endlessly, arranged and dissolved, formed and scattered, with no boundary to hold it. Suddenly, in these trembling spheres, there was focus. Chemistry inside was no longer just chemistry. It was enclosed chemistry shaped by the skin around it. Could it be that the dream of cells was simply this, the desire of molecules to hold on a little longer, to resist the ocean's dispersal, to create even for a moment the illusion of permanence? And yet, permanence was still an illusion. These membranes ruptured easily, torn apart by waves, by heat, by time. Most dissolved quickly back into the sea. But some reformed, sheltering reactions again. And again. In repetition, identity grew stronger. In patterns, memory became possible. In persistence, the dream of life began to take substance. Not because it was destined, not because it had purpose, but because chemistry tried endlessly against the silence, and eventually something remained long enough to call forward another moment, and another. We, looking back billions of years later, may wonder what it felt like for the first droplets of chemistry to enclose themselves. But perhaps wonder itself is misplaced, because to feel requires awareness, and these earliest selves felt nothing. They dreamed only because we interpret their persistence as a kind of dream. Yet in their boundary, something essential happened. The world inside became different from the world outside. And once difference exists, the possibility of awareness, however distant, is born. Inside protocells, cycles moved. Molecules copied themselves imperfectly, some breaking apart, others replicating with slight change. This was no longer chemistry alone. This was inheritance rehearsing itself for the very first time. Fragile, unstable, fleeting, but inheritance nevertheless. Could it be that identity began as nothing more than a hesitation, a pause in the endless dissolving of oceans? A pause that became repetition, a repetition that became survival, a survival that eventually became history. And if we follow that line, it leads to us. All our breath, our thought, our memory, comes from that first thin line drawn between inside and out. Just as protocells sustained the dream of persistence, so do we. We carry it in our lungs as air moves in and out, a reminder that even our bodies are membranes, fragile boundaries between the inner and the vastness beyond. Perhaps identity is always this. It begins in fragility, it survives by persistence, and it ends in dissolution. The dream continues through us, but it began in seas where no eye had yet opened. And yet, if membranes carried the spark of self, where did the energy come from to sustain it? What currents of invisible force transformed chemical pauses into processes that could endure? Life could not begin with walls alone. Containment was not enough. For order to resist dissolution, for molecules to replicate, for the fragile dream to become more than a momentary hesitation, there needed to be a way to harness energy. Something steady enough to be carried, something flexible enough to be shared. Energy, like water, needed a pathway. And slowly, life discovered its code. In today's cells, that code takes the form of ATP, adenosine triphosphate, a molecule so common within us that trillions are used and replaced every second, each acting like a tiny battery. It carries energy not by hoarding it endlessly, but by giving it up easily, breaking its bonds only to form them again. A cycle, endless and simple, so effective it became the universal currency of survival. Every cell on Earth speaks this chemical language. Every lineage relies on its flow. Could it be that behind all diversity of life there remains only one ancient economy, one common inheritance from the very first protocells? But ATP was not always here. Before it, there were other ways of trapping energy, reaching across gradients the way water climbs rock or rivers carve valleys. Heat flowing into cold, alkaline meeting acidic, minerals dissolving across tiny boundaries. All these differences contained possibility. What mattered was not stability but imbalance. Because imbalance invites resolution, and resolution makes work possible. Could it be that energy is not something life invented, but something life borrowed, a movement already shimmering through Earth long before the first cell formed? Within those first fragile membranes, gradients formed like invisible landscapes. Protons pooling on one side, absent on the other, creating a gulf that begged to be bridged. That bridge became metabolism, the delicate art of moving imbalance into pattern, of turning chaos into persistence. Life did not resist entropy outright. It learned how to make use of it, to direct the flow instead of opposing it, to carve from it the structures that lingered. Just as rivers find valleys, energy found its pathways inside the very first selves. We may imagine these earliest systems as primitive, but perhaps they were already profound. To carry energy in cycles is to carry time within matter. Memory for chemistry does not mean thought. It means process repeated again, each loop tracing the faintest footsteps of inheritance. What if the first dream of life was not replication but metabolism? Not the copying of molecules, but the sustaining of flow, the promise that energy could be captured for just long enough to maintain order against the sea's dissolving silence? Some scientists wonder if life began not in a single leap but in these twin developments, containment and channeling, membranes forming boundaries, gradients providing energy within them. Perhaps protocells did not simply dream of self, but of continuity, learning to tap into Earth's breathing cycles of heat and chemicals to carry themselves a fraction longer than chance would allow. A moment longer became many. Many became lineage. Lineage became history. And it is striking to realize that even now, billions of years later, every one of our cells still depends on this primal truth. Mitochondria, the quiet engines inside us, move protons across membranes in echo of those earliest gradients, charging ATP with each shift. The mechanism is the same in bacteria, in plants, in humans, as if life agreed upon this code from the beginning and never let it go. Perhaps because it worked, perhaps because once written, energy's code was too deeply etched into survival to ever be replaced. Energy, then, was not only chemistry. It was direction. It gave life something to follow, a path to walk against the natural dissolution of time. With energy came purpose, though not purpose as we would define it, only continuity, persistence made possible by flow. And perhaps in that persistence lay the first faint echo of something like intention, not because chemistry chose, but because it endured. Even now, when we exhale, when our blood beats oxygen across our bodies, when plants turn sunlight into sugars, when bacteria split minerals for sustenance, we are repeating the same act begun in those ancient seas, the act of capturing imbalance, of turning gradients into survival. We are echoes, repeating endlessly what Earth once discovered in silence. But if energy wrote the code that life followed, what of the paths that vanished, the metabolisms that no longer exist, the currencies of survival that might have come before ATP erased and forgotten? Could there have been countless other chemistries of energy, hidden and now gone, their memory etched only faintly into stone, if at all? And if so much has already been lost, how many other beginnings might remain hidden in deep time? What shadows of worlds erased could still linger in silence, carried on by stone and water, waiting for us to listen closely enough? Perhaps what we call the beginning of life was not singular, not one pristine event, but an endless chorus of attempts. Countless civilizations of molecules might have risen and fallen in those oceans, lineages without names, chemistries now dissolved. They left no fossils, no skeletons, no shells, nothing to ease our curiosity but silence. And yet, the silence itself may be whispering. Whispering that possibility is always wider than memory, and that most of what the Earth once tried has already been forgotten. Imagine oceans as vast arenas where chance performed its quiet experiments. Millions, billions of fragile assemblies forming and dissolving without witness. Some resembled protocells, forming membranes only to rupture. Others may have discovered fleeting metabolisms, harnessing gradients for a moment before collapsing. They could have spread, multiplied, lingered for centuries, even millennia, before vanishing back into the sea, erased without trace. Could it be that the ancestry of life was not a straight line at all, but a thicket of unseen branches pruned by entropy, trimmed by time, until only one thin lineage held on? This thought unsettles us because our stories prefer clarity. One beginning, one spark. But the Earth may not tell stories that way. Perhaps every trial mattered. Every false start paved a path even in disappearing. Chemistries that faded may have seeded conditions for others to succeed. A lineage erased may have left behind nothing visible, but everything it carried scattered, enriching waters where new beginnings could attempt again. Forgotten worlds pushing gently against the silence, shaping outcomes without enduring themselves. We see faint hints of these shadows in modern cells, strange enzymes whose origins remain unclear, metabolic shortcuts that may belong to ancient chemistry long abandoned. Even the genetic code we carry, universal to all life, might have displaced other systems, other codes that once governed inheritance but did not survive. Could it be that DNA itself is only one winner among many trials, chosen not by destiny but by resilience through eons of deep erasure? Maybe, maybe not. What lingers makes us certain, but certainty is always fractured by everything we can no longer see. Some scientists suggest that early Earth might have supported not one origin of life, but several, spread across separate environments. Some beginning in tidal pools, others in vents, others on mineral surfaces kissed by lightning. Entire molecular ecosystems may have coexisted, competing or even exchanging fragments of inheritance, before collapsing into the quiet. What if multiple versions of life overlapped once, sharing the planet until chance and time erased all but one? What if traces of siblings, ghostly relatives of our own ancestry, remain hidden in chemistry, waiting as echoes for us to guess at? But the silence is heavy. Heat and subduction recycled ocean crust countless times. Pressure and erosion wiped clean what might once have lingered in stone. If ancient civilizations of molecules existed, their ruins are invisible, scattered not in bone beds or fossil beds but in nothingness. And yet, perhaps erasure itself is testimony. For what would life mean if not for the improbability of what endured? The shadows of lost worlds remind us that the line between being and vanishing has always been narrower than we wish to believe. Possibility, then, is greater than memory. Our records mislead us into thinking survival is the rule when survival is the exception. What we know is a thin slice resting atop immeasurable silence. Could it be that life itself is a shadow, a rare survivor from countless other shadows that simply could not persist? If so, then we walk in a world made from ghosts, not only of animals and plants that flourished and died, but of uncounted molecular civilizations that flickered and dissipated long before the word fossil had any meaning. When viewed this way, the Earth becomes something closer to a dreamer, rehearsing countless lives before one lineage lasted, layering one silence upon another, accepting erasure as part of the script. Perhaps these ghostly beginnings are not failures but part of creation, attempts necessary for the fragile balance we inhabit now. We cannot touch them, we cannot study them, but their non-existence still shapes us. And yet, if entire molecular worlds could rise and vanish without leaving even a fossil behind, then how much else might Earth hold in silence? What traces remain unseen in isotopes, in mineral scars, in the chemistry of rocks too ancient to tell us directly? How can we know what else we have already forgotten? One of the only voices that survived that silence is the voice of isotopes. They do not speak in shapes like fossils, nor in landscapes like eroded valleys. Instead, they speak in ratios, in balances written into atoms, in quiet numerical poetry that hints at oceans long vanished, atmospheres long changed, climates that came and went before eyes existed to watch. Isotopes are memory without imagery. They are not stories, but fingerprints, the subtle hues of matter whispering that something shifted here, at a time past comprehension. Every element exists in more than one form. Carbon, oxygen, hydrogen. Each carries variants. Isotopes that differ only in mass, only faintly, yet profoundly enough that when they pass through oceans, rocks, or air, they leave distinct trails. In sediments, a slight change in oxygen ratios can tell us that ice once gripped the globe. In carbon trapped in rock, a fraction heavier or lighter can suggest whether ancient life was busy breathing in abundance or struggling in deprivation. In sulfur, signals are layered so faintly that they reveal not only chemistry, but the presence of volcanic skies, atmospheres alien to anything we know now. These small differences are, in a sense, letters of an older language. If we learn how to read them, they tell us that there were oceans for billion years ago, that they cycled, evaporated, condensed long before fossils existed. They tell us that oxygen rose once, expanding steadily, until life itself was reshaped by it. They tell us that atmospheres shifted, from suffocating to breathable, from heavy with methane to edged with clarity. They tell us that glaciers stretched so far that they almost buried the planet in white silence, only to retreat again. Isotopes do not dream, they endure. Their persistence is geology's quietest testimony. And yet, the language is imperfect. It speaks in whispers, not in clarity. To read isotopes is to interpret silences as much as signals. To hold a zircon crystal and measure its oxygen is to glimpse a water cycle we will never touch. To crush ancient minerals and weigh their ratios is to reconstruct the pulse of climates older than biology itself. But could it be that within those crushed stones, those faint ratios, there are entire forgotten chapters, worlds of possibility reduced to numbers we can only partly understand? It is rare to consider atoms as storytellers. They are so small, so stripped of imagery, that they seem alien to history. Yet if memory is simply what endures and points backward, then isotopes are memory's purest form. They are not written by intention. They are written because time passes, because physics insists, because decay and stability exist side by side within every atom. Maybe memory does not need awareness at all. Maybe memory resides in matter inevitably. The paradox, of course, is that isotopes also carry forgetting. Half-lives mean that clocks run out. Uranium becomes lead. Potassium becomes argon. The signal drifts toward silence as atoms change. Even enduring voices fade. Could it be that even in this quiet atomic persistence, the Earth insists on impermanence, reminding us that all records, even those etched in particle form, will one day blur into nothingness? We read isotopes as clocks, but they are clocks that erase themselves as they tick, telling us time's story while also consuming it with every beat. And so, through isotopes we glimpse both certainty and uncertainty. Certainty that oceans must have existed billions of years ago. Certainty that oxygen once shifted the very destiny of life. Certainty that ice and heat alternated in deep cycles, sculpting continents. But uncertainty too, about what was erased before those isotopes settled, about how many signals were melted, scattered, lost. They give us fragments, never wholes, whispers, never full songs. Perhaps memory is always made this way. More shadow than object, more absence than presence. Even now, as we devote instruments to their measurement, we must lean close, the way one listens for an almost inaudible sound in the distance. Faint signals emerge, but interpretation remains tentative, fragile. One scientist reads climate, another reads atmosphere, a third reads evidence of life's earliest oxygen breath. Maybe all are correct. Maybe each is only seeing part of the truth. Maybe truth itself, in deep time, is not singular but diffuse, like mist dispersing on a lake. And there is an intimacy in this. To read isotopes is to realize that Earth has always been written upon, not by humans, not even by life but by matter itself. Every atom is a marker, every ratio a trace of what has once been. In this sense, the memory of Earth is deeper and more pervasive than we imagine. Written in every grain, in every crystallization, in every layer not consumed by tectonic hunger. Even the smallest fragment tells us something, provided we have the patience to listen. And yet, if isotopes are the faint letters of a world without witnesses, then what of the clays and minerals that not only recorded but instructed, that both remembered and taught? If stone could shape memory, perhaps stone could also shape destiny. Clay is humble. It accumulates in quiet places, river mouths, tidal flats, the still basins of shallow seas. At first glance, it is only mud, only the simplest residue of weathered rock ground down to its finest form. Yet within this unassuming dust are structures of astonishing patience. Clay arranges itself in sheets, thin planes stacked like pages of a book. Each layer carries charges, attracting molecules to cling, arranging them in ways they might not have chosen on their own. To the human eye, invisible. To chemistry, essential. What if life itself was first whispered into order here, in these layered landscapes of crystal sheets? The theory is simple but profound. Clay acted not only as a surface but as a template, guiding fragile molecules into repetition. Chains of nucleotides, vulnerable in the dissolving water of open seas, could rest against clay's charged layers, aligning, copying, learning to persist in patterns. In this sense, clay was both memory and teacher, holding arrangement just long enough for inheritance to be imagined. Perhaps every spiral of living code began as a reflection pressed into mineral pages. Could it be that inheritance, one of life's most mysterious capacities, did not come from fragility alone, but from patience borrowed from the earth's own skin? Clay had always been there, an outcome of erosion, the grinding down of mountains into silt and dust. In its quiet accumulation, it became something more than landscape. It became scaffolding for memory, not because it intended to, but because its structure allowed it, because repetition is embedded into its very being. And still, we cannot know for certain. Perhaps clay's role was central. Perhaps it was peripheral. The silence of deep time does not yield full answers. But speculation itself carries wonder. The persistence of clay reminds us that the simplest, softest matter might hold the greatest significance. What if the foundation of our lives, every thought, every breath, every lineage, was sparked not in storms or fire, but in mud beneath ancient seas? Even today, clay persists in roles we overlook. It preserves fossils by holding their impressions tightly. It filters water, purifying by absorbing what is harmful. It carries memory not only from chemistry but from culture. Humans shaped it into tablets to carve writing, baked it into bricks to build early cities. Perhaps our own memory, the stories we preserve with words, began with clay as well. How strange that both biology and civilization may trace their roots to the persistence of this overlooked mineral. Maybe it has been our silent companion from the very beginning, repeating its patterns in echo through every scale of time. But clay does not hold everything. Its layers, too, are subject to erosion. Its patience, though vast, is not eternal. Sediments shift, pressures transform, minerals recrystallize, and the earliest inscriptions vanish. Silence joins remembrance once more. Could it be that clay offered only fleeting windows of possibility, fragile scaffolding that tested patterns until some could sustain themselves, freed at last from reliance on stone? If so, then clay's greatest role was not permanence, but letting go, allowing what arose within it to carry memory onward in a new form, independent yet indebted. We see this in DNA itself, spiraled and repeating, a structure whose persistence echoes the layered order of minerals. Patterns translate into other patterns, cycles into cycles. The lesson of clay did not vanish. It evolved, carried into life's own code. When we contemplate inheritance, perhaps we are still hearing echoes of those earliest mineral teachers, the geometry of stone folded into the rhythm of biology. The persistence of clay is not only in survival. It is in the memory of form, repeated so patiently that even when the material disappears, the lesson remains. Repetition itself became the bridge across silence. Clay rehearsed order long before cells did. Clay folded molecules into practice long before ribosomes copied them. Clay was the patient tutor of structure, even as its body was erased by erosion, even as its layers were rewritten by pressure and change. Could it be that memory, in its deepest sense, has always required teachers, places where fragility could rest long enough to learn endurance? And yet, if clay provided the structure for life's earliest code, then what of the greater law that pressed upon it? The law of entropy that dissolves all order eventually into chaos. What does it mean that persistence must always balance itself against disorder, and that the very endurance of clay is shaped by the same forces that erase it? Entropy is often called the tendency toward disorder, the fate that all systems share. Heat disperses, energy scatters, structures collapse, and memory fades. In the scale of the universe, entropy is the arrow that moves everything forward, dissolving order into simplicity. And yet, here upon this planet, amid all this scattering, order rose. Molecules aligned, patterns repeated. Life began. Why does order arise at all when the universe leans so strongly toward forgetting? The dilemma is not one of science alone. It is philosophical, even existential. Entropy insists that beginnings should crumble. And yet, beginnings ignite anyway. For every molecule folding into chaos, another discovered how to cling. For every pattern erased by dissolution, another managed to repeat, to copy, to linger. Life was not a defiance of entropy but a strange collaboration with it, a pause within its current, a rhythm that slowed loss just long enough for memory to emerge. Perhaps the answer lies not in resisting entropy but in using it. Every cell alive today relies on entropy's gradient, energy flowing from high concentration to low, electrons moving downhill, bonds breaking and releasing their stored gifts. Life turned loss itself into opportunity, turning the fall into momentum, riding the law instead of fighting it. Could it be that all order is temporary resistance, sculpted briefly out of the very collapse that will one day undo it? That continuity is less a victory and more a delicate balancing act carved in the stream of dissolution? Even the simplest reactions reflect this truth. Heat mixing into cold, gases dispersing through air, nutrients breaking down in water, all are entropy at work. Yet, when captured within membranes or bent around the scaffolds of minerals, these same flows became useful. They drove reactions forward, gave structure to molecules, powered the fragile persistence of protocells. Entropy erased endlessly, but its erasure created movement, and movement created possibility. Maybe it is accurate to say that entropy has always been both destroyer and teacher. Still, we cannot ignore what this means for all things that live. If entropy cannot be stopped, only danced with, then order, life, memory, identity, must always be temporary. Every beginning carries within it the inevitability of its own unraveling. Even the sun one day will scatter its heat into cold silence. Even the universe itself drifts toward a stretched thinness, a cosmic forgetfulness where all differences fade away. Against this backdrop, life may seem fragile, even futile. And yet, here it is. Here we are. Here is Earth, still writing order against the current, still carrying inheritance forward despite entropy's pull. The dilemma becomes wonder when we look closely. Why does order arise at all? Why does chemistry not simply dissolve into chance forever, without structure, without persistence? Why do galaxies cluster? Why do stars form? Why do molecules self-assemble into cells? Perhaps order arises simply because the universe allows it, because entropy is not an instant collapse but a long drift, and in the pauses there is space for shape. Or perhaps there is something deeper. Perhaps the tendency of matter to structure, briefly and beautifully, is as fundamental as its tendency to dissolve. Maybe both laws are equal companions, one pressing outward, the other folding inward, together shaping the story of existence. And in this balance we find ourselves. Not because life once and forever overcame entropy, but because life learned to borrow its currents, to adapt to its inevitability, to use flow as persistence. We are, in a sense, living paradoxes, temporary beings holding continuity in defiance of dissolution, aware that we cannot last but continuing to repeat anyway. Every breath is proof of this. Every cell, every heartbeat, every moment of memory is an act of resistance written briefly in molecules, etched for now, erased eventually. Maybe this is why silence feels both haunting and calming. It mirrors what we know at the edges of thought, that endurance is only borrowed, that absence waits patiently. But maybe this is also why life feels so precious, because its persistence is improbable, delicate, written against the grain of time. Could it be that meaning itself arises from this tension, that we only sense purpose because we know dissolution is inevitable? And yet, if life is resistance carried through molecules, writing shapes against the current of entropy, then what of the spaces between, those long silences that stretched before life began, and that may stretch again after it ends? Is it possible that absence, too, carries its own kind of memory, waiting in stillness for what comes next? Silence is not empty. Silence is not nothing. It is the pause in which pattern gathers, the breath in which possibility ripens, the background against which emergence can be seen at all. Before the first cells left their mark, there were eons of silence. Oceans swirled, minerals crystallized, volcanoes roared, storms flashed. Yet no life yet spoke the world into continuity. That silence was not barren. It was pregnant. A waiting silence, full with chance and chemistry, full with moments rehearsed and erased. If life began once, could it begin again? Or does beginning draw upon silences so vast, so deep, that repetition is more fragile than we dare imagine? Between great events in Earth's past, there are also silences written in stone. Mass extinctions that cleared ecosystems, only for long ages of quiet recovery to follow, when survivors spread slowly into the spaces left behind. Geological upheavals that buried whole regions, leaving gaps, unconformities, pages ripped from the manuscript of rock. Between eruptions of creativity, between flourishing and collapse, silence always intervenes. It is not absence, but transition, a kind of planetary breath. Could it be that the intervals of quiet matter as much as what fills them? That, without silence, creation would have no room to take root? Even in the fossil record, these pauses exist. Whole ages pass with little trace, then suddenly new forms appear, as though from nowhere. We often celebrate the burst, the Cambrian, the flourish. But perhaps we forget that the silence between is what prepared the ground. What looks to us like stillness may have been full of unseen trials, worlds of chemistry rehearsing themselves without success, or fragile lineages rising and dissolving before they could persist. Absence leaves room for novelty, the way an empty canvas is needed before paint can spread. And so, silence itself becomes a witness. It shapes what will come by what it withholds, by its spaciousness. Even in our own perception, we hear music only because of rests between notes. We read meaning into words only because of spaces between letters. Could it be that life itself adheres to the same principle, that the silences between emergences are not nothing, but everything? In deep time, silence stretches impossibly far. An event at 1 billion years, then quiet until the next turning 500 million years later. To us, who live inside narrow decades, such gaps feel like eternity, but Earth carries them as naturally as inhaling and exhaling. Breathing ice, breathing warmth, breathing collapse, breathing possibility. Each silence is not the end but the space in which new rhythms find themselves. And yet, what does this mean for us? If life could begin once, does silence still hold unspent potential, waiting for another beginning? Could the universe itself be full of silences, each of them rehearsing, each holding its breath until one molecule in one ocean somewhere happens to persist? Could beginnings be as common as raindrops, scattered across worlds, most erased, some surviving long enough to sing? Or are beginnings so rare, so fine-tuned, that the silence between them stretches farther even than galaxies, a near-infinite weight across space and time? The silence between emergence humbles us because it reveals how little we know. We cannot see into those gaps. We do not know what was lost there. All we glimpse are beginnings and survivals, never the silences in which they gestated. But perhaps this is enough. Perhaps knowing there are silences reminds us to wonder, reminds us not to fill every pause with certainty, but to rest in what remains unspoken. Even in ourselves, silence shapes identity. Between thoughts, between breaths, between moments when memory stirs and then recedes. Maybe we carry echoes of these planetary silences within us, our own rhythms stretched and folded the way Earth once stretched hers. The silences are part of who we are, even if we do not name them, even if we cannot fathom their depth. And still a question ripples forward, patient and open. If silence is always twin to emergence, then what archives remain hidden in that stillness? If what survives is small compared to what dissolves, then what else, buried, erased, forgotten, might reappear only faintly, not in bone or stone, but in the chemistry of Earth itself. Earth's most enduring archives are not fossils, not skeletons turned to stone, nor shells preserved in rock. Those belong to later chapters. The earliest stories are written in sediments, in grains washed from mountains, in veins of minerals weaving through the crust, in layers pressed together so tightly they form textures we barely notice. Memory here is not narrative. It is texture, chemistry, presence, and absence. It is the softest accumulation, yet it endures longer than most lives ever will. Every river carries fragments, eroded from stone, pulled as sand toward the sea. Each particle is a page without words, a grain that remembers the rock it came from, even if only faintly. Over time, sediments bury each other, layers stacked like whispered breaths, each compressing the last. These layers are like shelves in a library without books. They do not tell us everything outright, but in their composition, in the isotopes they contain, in the minerals aligned within them, we catch echoes of vanished climates, lost atmospheres, seas transformed beyond recognition. Could it be that the planet writes itself not in sentences or chapters, but in textures layered upon textures, each one a fragmentary memory carved into silence? Mineral veins tell stories of circulation deep within the Earth. Fluids flow through fractures, carrying dissolved elements, crystallizing them in hidden passages. Quartz and calcite, hematite and pyrite, they fill cracks like veins of memory, storing chemical signatures of the conditions in which they grew. To the passing eye, they are only color and pattern, but to careful study they are history. Temperatures recorded in crystal growth, pressures remembered in alignment, elemental ratios preserved for billions of years. Even in darkness, without witness, the Earth writes itself. There is something mesmerizing in realizing that memory does not need intention. Sediments do not try to preserve, but they do. Mineral veins do not try to remember, but they hold. It is a silence so profound it almost escapes us. We are accustomed to memory as narrative, as story. But here memory is not story, it is structure. It is the weight of grains aligned, the repetition of layers stacked, the quiet endurance of a mineral seam stretching through stone. Perhaps the Earth does not tell stories in the way we wish it would. Perhaps it shows us textures that can only ever be partial, a language we do not yet know how to fully read. And yet, these archives are incomplete. Subduction consumes ocean floors, dragging sediment down into the mantle where it melts, erasing whole libraries of memory. Erosion strips mountains bare, carrying layers away grain by grain until they vanish. Heat and pressure metamorphose old rocks, rewriting their chemistry, replacing what was once clear with new textures that obscure the past. For every layer we can read, countless others are erased. For every mineral vein preserved, many more dissolve into silence. Could it be that all archives, even Earth's, are more absence than presence? More missing words than written ones? Still, we must treat what endures with reverence. In Greenland, ancient sediments tell us of oceans 4 billion years old, oceans older than any life we know. In South Africa, banded iron formations are silent witnesses to the first rise of oxygen. Their reddish seems proof that something in the sea began to breathe. In Australia, zircons carry isotopic memories of liquid water long before the earliest known organisms. These archives are not complete sentences, but scattered words. Not paragraphs, but fragments, broken lines. And yet, even fragments are enough to remind us that the story is vast, and that forgetting is as much a part of its telling as remembering. It may be worth asking, what is memory without narrative? Can texture alone remind us of what has passed? Perhaps it can. Texture grounds us not in plot but in presence, reminding us that something was here, whether or not we understand it fully. A grain of sand may not tell us an entire chapter, but it holds the mineral truth of its origin, the erosion that freed it, the river that carried it. A mineral vein may not tell us who or what took form in its time, but it holds the pulse of heat and water moving invisibly through stone. Memory, then, is not only about completeness. It may also be about impression, shapes, colors, isotopes, patterns felt more than spoken. And yet, if memory can exist as texture, silent and incomplete, bound into sediments and minerals deeper than any fossil, then what of the larger cycles that shape them? The breathing of carbon, oxygen, nitrogen across deep time, rhythms older than cells, older than breath itself? The earth has always inhaled and exhaled, though not with lungs and windpipes, not with flesh and rib cages. Its breath belongs to the cycling of elements, whispering across oceans, seeping through stone, drifting into the sky. We measure it now in isotopes and sediments, but long before we named it, this breath was moving, carbon into air, carbon into rock, nitrogen dissolving into seas, oxygen rising and falling with possibility. Each cycle was a pulse, slow and immense, shaping not only landscapes but the very possibilities of life itself. Carbon is perhaps the oldest storyteller among them. Born in stars, drifting as dust, it found its way into stone, into water, into air. When carbon dioxide thickened the atmosphere, Earth warmed, oceans steamed, climates surged toward chaos. When carbon was drawn down into limestone by the shells of later creatures, or captured in coal and kerogen, Earth cooled, allowing glaciers to spread. Even before creatures added their influence, volcanoes outgassed carbon into the air, while weathering stone drew it back again. A balance, fragile and endless, sets the rhythm of habitability. Could it be that every experiment in being, every fragile attempt at life's continuation, was permitted or extinguished by the rise and fall of carbon's breath? Then came oxygen, a stranger to the early atmosphere. At first, oxygen was scarce, a trace produced only by chemical reactions in the sky. Later, microbes began to exhale it as waste, cyanobacteria turning sunlight into food, spilling oxygen into waters that had never known it. At first, this was poison. For lineages that had survived on chemistry alone, oxygen was catastrophic. Entire ecologies must have faded into silence. And yet, from this toxicity, new opportunity arose. Oxygen proved a powerful energy carrier, something that allowed cells to breathe more deeply, to grow more complex, to imagine structures larger and more elaborate. Could it be that what we now call life's progression was shaped as much by suffocation as by survival, as much by extinction as by invention? Nitrogen, though quieter, has always been essential. Bound in proteins, embedded in DNA, it is one of life's most persistent elements, and yet it is difficult to access. In the atmosphere, nitrogen is abundant but locked into bonds too strong for most organisms to break. It took certain archaea and bacteria to unlock it, fixing it into soils and waters, turning it into food for others. The nitrogen cycle was hidden, an underground current enabling inheritance to continue. Without it, life could not have flourished, and yet its traces are barely visible in the record. Nitrogen whispers rather than declares, quietly holding life's architecture together without demanding notice. Together, these cycles formed Earth's ancient breath, sometimes calm and balanced, other times volatile and extreme. Glacial ages froze whole oceans when carbon fell too low. Hothouse epochs boiled seas when carbon surged too high. Oxygen events transformed seas rust-red with iron into blue waters ready for complexity. Nitrogen pulses shifted fertility across oceans and soils, driving bursts of abundance and collapse. In every age, life was not separate from these breaths but deeply entangled within them, carried along like dust floating inside wind. To say life adapted is true, But perhaps it is also true that life became an extension of the cycles themselves, another way for the planet to breathe. When we speak softly of Earth's memory, perhaps this is what we mean, the memory of breathing, written across eras, patient but also unpredictable. Breath is repetition, but it is never identical. Each inhale blends slightly different gases. Each exhale returns something altered. Maybe life, too, is not about resisting the cycles but about harmonizing with them, finding fragile stability within their fluctuations. And yet, these fluctuations have always carried danger. Too much oxygen once burned the world into flammability. Too little, and oceans collapsed into suffocating stagnation. Too much carbon welcomed hothouse seas in which only a few could endure. Too little, and ice spread, locking the planet in shining silence. Every experiment of life was tested first against these cycles, permitted if it could endure, erased if it could not. Could it be that, in the very breath of the planet, we hear both the voice of creation and the shadow of erasure at once? Even now, as we breathe, we echo rhythms older than lungs. Every inhale of oxygen, every exhale of carbon dioxide, is not only physiology, it is ancient geology, still alive within us. The rising and falling balance of gases did not merely allow our lineage to survive. It shaped it, wrote itself into our blood, into our need to inhale and release in endless repetition. We are, in that sense, breathing Earth's own memory, carrying fragments of its elemental cycles inside us. And yet, if even the atmosphere carries memory in its shifting compositions, then what of the absences? What of the cycles buried deeper, erased in full, hidden beneath the surface? What does it mean that entire chapters of Earth's breath have already vanished, carried beneath mountains, lost to subduction zones, consumed in silence? The Earth, restless and alive with its own movements, has always been both an archivist and an eraser. Much of its first history is gone, not because it was never written, but because it was devoured by the very planet that bore it. Oceans floor against continent, one slipping beneath the other, into the mantle's heat where stone melts, minerals dissolve, and records turn once more into molten anonymity. Volcanoes rise, burying older layers beneath fresh surges of basalt. Winds grind mountains into dust, rivers sweep that dust into seas, glaciers scrape valleys into silence, and tides scatter every trace. What remains, scattered and fragile, are fragments, single pages from an infinite book, torn away from their binding. The oldest rocks on Earth are vanishingly rare. Here and there, in Greenland, in Canada, in Australia, crystals of zircon shimmer older than continents, older than life. They are exceptions, grains that somehow survived cycles of destruction, carrying isotopic signatures of water and atmosphere long disappeared. To hold them is to realize how much is missing. For every crystal that endured, millions were erased. For every page we can read, whole volumes have been consumed by fire, buried in pressure or worn to silence. Could it be that most of Earth's earliest story is not lost but deliberately hidden, as if the planet has been learning to keep secrets since its beginning? Geologists speak of unconformities, gaps in the rock record where entire epochs are missing. Sometimes hundreds of millions of years simply vanish between one layer and the next, as if the story leapt ahead without warning. One moment a sea floor, the next a desert, with nothing in between preserved. Where did those centuries of oceans and forests go? Into erosion, into subduction, into recycling so complete it left no mark we can read. These absences are not mistakes. They are the nature of the Earth itself, restless, reshaping, wiping away its own past even as it creates the future. It is humbling to think that most of what happened we will never know. How many lost atmospheres, gone without trace? How many ancient climates erased entirely? How many early creatures lived, thrived, and disappeared before leaving even a whisper in stone? Perhaps more than we realize, perhaps more than what survived. In this way, forgetting is not an accident of history but a law as profound as gravity. Memory is fragile. Silence is patient. Earth is always reshaping, always concealing, carrying within it vast archives no eye will ever see. Still, fragments remain. Isotopes hint at vanished seas and skies. Sediments preserve the texture of worlds altered long ago. Mineral veins hold traces of fluids that once pulsed through stone. Together they tell part of the story, but the larger part is written in silence. We read what remains, but we must also learn to read what is missing, for absence itself is a kind of testimony. Perhaps the planet has always whispered not in whole words but in incomplete ones, leaving us to imagine the rest. Maybe this is how Earth teaches, by what it covers as much as by what it reveals. And here lies the paradox. What has survived seems astonishing only because of how much has been erased. The few pages left are enough to remind us that an entire book once existed, unbound now, scattered by entropy and geology. We hold fragments and call them the past, knowing they are surrounded by infinities of forgetting. Could it be that memory itself is not the record but the gap, the tension between what is kept and what is erased, what endures and what dissolves? And if the planet has always hidden its earliest chapters, if most beginnings have been swallowed into silence, then how do we imagine what might have existed before lips ever told stories? What lost technologies of nature, what versions of matter and order, might lie beyond our grasp, erased so fully that all that remains are the questions they left behind? When we speak of technofossils today, we usually imagine our own traces, the plastics, alloys, and concrete that will one day harden into geological signatures, artifacts written into rock layers as evidence of us. A mark of human technology, imprinted for ages to come, even if memory of us fades. But what if the Earth had technofossils long before us, structures of stone and molecule that served as the first silent technologies of nature? A technology does not have to be built by hands. A technology can be any arrangement that performs a function, any system that carries forward the work of persistence. What if clays, crystals, and minerals were not merely landscapes, but early devices, surfaces that structured molecules, frameworks that etched repetition into chemistry? Minerals templated, organized, guided. They did not choose to, but they did. Could this not be technology? A pre-life form of invention, made not with intention but with inevitability? Think of a crystal lattice. Its geometry repeats without flaw, atoms stacked upon atoms in rhythms as precise as any code. To molecules adrift in restless oceans, these lattices became patterns to rest against, aligning them into order that chaos alone could never have achieved. The surface acted like a machine, invisible to us now, helping molecules copy themselves, stabilize themselves, hold their form. A silent technology, not crafted but discovered, embedded in the fabric of stone. Or think of hydrothermal vents, towering chimneys of mineral where water and fire met. Their porous walls created tiny chambers, gradients etched through mineral by heat and fluid. Each pore functioned like a cell before cells existed, a container, a prototype of enclosure, where balance could be tested and energy harnessed. These structures were not alive, but they performed as living laboratories, natural reactors shaping molecules into paths that might lead toward inheritance. Could it be that stone built the first architecture of life, long before biology continued the design? Even molecules themselves, once they discovered repetition, became a kind of tool. RNA strands may have acted not only as carriers of inheritance, but as catalysts, capable of encouraging reactions forward, easing chemistry into directions it would not naturally take. This, too, is technology, not mechanical but functional, a scaffold invented not by hands but by necessity. Life, when it arrived, did not start fresh. It inherited these natural technologies, refined them, adapted them, carried them forward. Perhaps technofossils, in this broader sense, are not future remains of our civilizations but ancient remains of Earth's own ingenuity, the ways in which matter itself devised continuity, performance, structure. Not because it planned, but because it followed the flows of physics and chemistry with patience beyond our imagination. Maybe when we hold a crystal, when we examine layered clays or the pores of vents, we are not only looking at geology but at technologies older than life. Tools that made life possible, tools that endured by becoming invisible. And still, as with all memory, most of these traces are gone. Subduction swallowed vents whole, clays were eroded and buried, molecular experiments dissolved into silence. What remains are only hints, faint fossils of processes rather than creatures. But maybe that is what a technofossil really is, a trace of function, not of form. A hint that something once worked toward persistence, even if it left behind no skeleton, no shell, no narrative. There is humility in realizing that our own technofossils, plastics, alloys, fragments of machines, may one day lie beside these more ancient ones, signatures of persistence written into stone. But will they carry the same meaning? Our inventions are shaped by intention, driven outward by use. Earth's were not. Its technofossils were accidents of physics and chemistry, chance arrangements that became essential scaffolds. Could it be that all invention, even ours, stems first from this? That our buildings and machines are distant echoes of natural designs practiced long before in stone and molecule? Maybe when future beings, if any, study remnants of us, they will see us through the same lens, we too part of a long continuum of technologies, beginning not with industry but with clay and crystal, with molecules folded against minerals, repeating until repetition became life. In this way, the technofossils of pre-life are not mere curiosities. They are the deep ancestry of invention itself. And yet, if minerals and molecules could carry function without thought, could build silent tools without needing hands, then what does that mean for us, for the self we so carefully guard? Is it possible that even what we call self is only another emergent device, another technology built not of stone but of memory, persistence curving briefly against time before vanishing into silence again? To search for life's beginning is to ask about our own. For the fragile birth of the first cells is not merely an ancient question of geology or chemistry, it is a mirror. Within those earliest fragile membranes, where chance arrangements found repetition, lies the shadow of every future perception, including ours. To look back at them is to look back at ourselves, not at our bodies or our thoughts, but at the trembling threshold where matter first began to dream of continuity, first began to draw a line, however faint, between inside and outside, between me and not me. The first cell was not aware. It did not know. And yet, in enclosing itself, in shuffling molecules inward rather than outward, it carried forward a gesture so profound we can still feel it echoing. To persist in distinction, to create order within disorder, to hold identity, however simple, for just long enough that it may be passed on. That gesture has traveled across billions of years and arrived in us, shaping the way we breathe, the way we remember, the way we perceive the boundaries of our own lives. Could it be that our selfhood is only the inheritance of that first hesitant closure, amplified through time into consciousness? Every cell today, whether in leaf or animal or fungus, enacts the same truth. Each holds membranes against chaos. Each carries chemistry forward by tracing cycles older than stars. What we call identity may simply be ancestry grown complex. Our sense of self may not be invention but continuation, the same fragile insistence on persistence that first pulsed in oceans long vanished. Maybe the great paradox is that the self feels eternal, yet it was built from a process that, at its beginning, was anything but eternal, fragile, temporary, dissolving as quickly as it began. Is it possible, then, that what we call I is just the persistence of this ancient gesture, carried forward and amplified until perception itself awoke? Could thought be only a more elaborate extension of a pattern born in simplicity, imagination just another layer of the same ancient boundary? Maybe, maybe not. But every part of us still echoes the decision those first membranes made. To hold on, however briefly, to declare distinction in a world that pressed constantly toward erasure. There is humility in this reflection. For if the self arises from such fragile origins, so easily erased, what does it mean for identity to be temporary? Perhaps it means that there is no strict boundary at all. That self is both real and illusion, both gift and accident, both presence and echo. Just as clay offered its scaffolds only to let molecules slip free, so too the planet may have offered selfhood only as a fragile experiment. What survives is not certainty, but willingness to hold the question open. Geology, in its indirect way, supports this. The oldest microfossils, if they are fossils at all, are no more than films of carbon pressed into stone, debated endlessly by those who study them. Do they show life, or only chemistry pretending to be life? The ambiguity itself teaches us something. We do not know where the self begins. We know only that the record blurs at its edges, dissolves into silence. Could it be that self is always like this? Too clear to deny, too fragile to confirm, too entangled with absence to draw a final line? And when we extend the thought further, when we imagine that our self sits atop a chain of cells, atop molecules, atop atoms that never thought nor perceived, we begin to sense a continuity unsettling and profound. We are the cosmos folded inward into memory. We are the earth rehearsing persistence through us. We are the long shadow of molecules dreaming continuity through chemical imitation until thought itself grew. Maybe consciousness is not so much invention as inheritance. But if this is true, if the self is only one expression of a deeper persistence, carried across unfathomable spans, then what happens when memory is erased? What happens to the self when even identity dissolves, as it surely one day must? Does something continue? Or does it vanish like those first fragile cells, absorbed back into silence? Could it be that self, too, is less absolute than we think? Merely one more shadow in the great experiment of time? And yet, if all of us are descended from that first trembling boundary, if selfhood began as a fragile line drawn in chemistry, then perhaps even now, in every breath we take, there remains an echo of that moment. And if the self itself is so ancient, then what of the persistence of time's echo? What traces of beginnings might still be moving through us, connecting us to everything that ever was? Life's persistence is itself a fossil of beginnings. We imagine fossils as bones pressed into rock, or shells preserved in stone. But fossils take many forms, and some are not shapes at all, but continuities that endure across impossible spans. Every cell alive today, whether in a tree, in a microbe, or in the body of a human, carries with it the inheritance of oceans that no longer exist, codes that were written billions of years ago when the first membranes trembled into place. Every breath we take is an echo of atmospheres long gone, air transformed countless times, but still carrying the rhythm first written when molecules learned to inhale sunlight or exhale energy. Could it be that we, in our ordinary persistence, are living fossils, not records of what has passed, but embodiments of what continues? When we exhale, carbon drifts back into the air. That carbon may once have formed part of limestone deposited by creatures hundreds of millions of years ago, or drifted in the belly of a star before Earth was born. When we breathe, we not only animate ourselves, we extend inheritance, carrying forward a process that began in oceans no human has ever seen, oceans that exist now only as signature in stone and isotope. The echo moves through us, unchanged at its core, even as everything around it has shifted. Every organism alive shares this continuity. Each one passes along molecules, mutations, memories of chemistry, stretching back without break to the origin of life itself. There has been no interruption. The chain has never snapped. It is as though the first fragile lineage that clung to persistence still continues, unbroken, unfolding through countless bodies. This, in itself, is fossilization, though not into rock but into being. To exist is to carry the residue of all that came before. A memory not chosen, not recalled, but enacted in every heartbeat, in every replication of DNA. And it is not only cells that carry the echo but landscapes as well. The deserts we walk were once seabeds where early creatures left traces, whose dust we now breathe unknowingly. Mountains carry oxygen isotopes forged in ancient climates. Rivers trace veins of chemistry drawn out from stone older than life itself. Everywhere, inheritance continues, not just in biology but in geology, in water cycles, in the very patterns that still press continuity against entropy. Perhaps all persistence is fossil, all memory embedded in endurance itself. There is an intimacy in realizing this. To touch your own skin, to feel a breath, to blink in thought, is to feel the continuation of patterns begun in eras so distant there was not yet a sky like ours, not yet continents, not yet forests or creatures to name the earth. We are fossils that move, fossils that speak, fossils not preserved in the stillness of stone, but in the motion of repetition, carrying time's first successes forward without pause. Could it be that we are, more than anything else, fossils disguised as selves, keeping the echo alive? Sometimes this inheritance reveals itself in faint detail. Mitochondria inside our cells, the powerhouses of energy, are remnants of bacteria long ago absorbed into larger organisms. We carry them not as guests but as parts of our own being, yet they whisper the memory of older independence. Similarly, parts of our immune system point back to ancient viruses that, though destructive then, became part of us, written into our code, shaping what could persist. Ghosts of worlds long dissolved live on within us, reminders that survival is memory embodied, not only in stone but in flesh. And yet, alongside all that persists, there is silence. So much has been erased. So much is absent from the chain. Oceans that carried beginnings no longer exist in their original form. Atmospheres have changed countless times, becoming unrecognizable. Even cells that survived did so through extinctions that claimed innumerable others whose echoes went still. We carry forward, but we also carry within us the reminder of forgotten companions, lost chemistries, erased chapters. We are echoes not just of survival but of absence. Perhaps this is what makes persistence itself a kind of fossil, the awareness that it could have ended at any time and yet it did not. The chain has stretched across impacts and freezes, across oxygen floods that poisoned as much as they created, across silences long enough to feel like erasure. Still, here it is, alive in us. Life's persistence is a fossil not carved in stone but enacted through time. It is the longest fossil of all, one still unbroken, one still writing itself through us. And yet, if this echo still carries forward, unbroken from oceans that no longer exist, it draws us toward the final question. If every self, every body, every breath is already a living fossil of beginnings, then what remains of the first mystery itself, the unanswered question of what Earth was like when life began? We arrive slowly where we began, at the threshold, at the question that lingers even after centuries of study. What was Earth truly like when the first fragile stirrings of life arose? We circle it, glimpse it through fragments of zircon, through scars pressed into stone, through isotopes whispering of vanished seas. But the answer resists. It remains open, as if the Earth itself has chosen to keep this memory sealed within its silences. And so we, like countless generations before us, are left not with certainty but with wonder. The early Earth was not the steady companion we know now. It was unstable, breathing heat and fire, restless with volcanic storms, shrouded in an atmosphere unfit to breathe. Lightning split skies heavy with methane and carbon dioxide. Oceans foamed with dissolved metals, minerals spilling into waters that seethed as much as they calmed. Continents were not yet continents, shifting crust wandering across the globe in fragments of stone still finding balance. It was a world unsettled, a world without stillness. And yet, in that chaos, life found possibility. We picture oceans as silent cradles, but perhaps at their beginning they were more like laboratories, filled with storms, collisions, dissolutions, molecules united and separated, endlessly repeating rehearsals never meant to last. In lightning, in heat, in gradients between vents and tides, possibilities expanded, collapsed, expanded again. Millions of beginnings ended before they could matter. Millions more dissolved without leaving a trace. And yet, among those vast failures, one fragile experiment endured, long enough to carry itself into continuity. Not because it was destined, but because timing and chance leaned toward persistence. The mystery is not only how life began, but why it continued. Why out of chemical storms did something emerge that could repeat itself? Why against entropy's constant pull did a structure choose order, if only briefly? Why did that order not collapse as so many others had? Could it be that the question of origins can never be answered in facts alone? That it is as much a meditation on chance and silence as it is on chemistry? Maybe the Earth will never tell us directly. Maybe it is not supposed to. And so we ask ourselves, if life began once, could it happen again? Not elsewhere, on distant planets, though that too is possible, but here, even here, if all were erased, if oceans were emptied, if atmosphere vanished, could some future epoch birth life again? Or was that first beginning so rare, so fragile, that it is a miracle we exist at all. We do not know. We may never know. But in that uncertainty lies humility, and in humility, wonder. Even in the absence of answers, the echoes remain. Every drop of rain still follows cycles begun billions of years ago. Every river still erodes mountains into silt, as rivers did when the first cells took shape. Every breath still relies on gases balanced by processes born in unseen oceans. It is as if the world itself carries reminders. Not in words, not in stories, but in repetition. Not because memory chooses, but because persistence itself is memory. When we wonder about the first mystery, we join a lineage not only of organisms but of questions. Countless have asked before us. What was this world like when life was new? When dawn had no name? When silence was still the planet's only language? The question has traveled further than any fossil, endured longer than any mountain. Perhaps the question itself is the true inheritance, the one thing never erased in cycles of geology and extinction. Perhaps to ask what was Earth like then is to feel the deepest thread connecting us to everything in the beginning. And maybe this is the answer, not certainty but sharing. We do not witness the first breaths of chemistry becoming inheritance, but we share their silence. We do not hear what oceans sounded like when no life had yet stirred, but we share their patience, leaning forward into the unknown, listening as they once did. We do not know how the fragile boundary of the first cell arose, but we share its persistence, carrying the same gesture in every cell that composes us now. To live is to be part of this continuity, to hold within our bodies both the silence of erasure and the persistence of beginnings. So we return to the mystery that cannot finish, to the silence that will not unveil itself completely. What was Earth like when life began? A place of fire, of storm, of endless dissolution. A place of oceans that whispered possibility, a sky unsettled, a crust reshaped with each passing age. A world raw with patience, trembling with chance. And in all of this, a fragile voice arose. Not a spoken voice, not even a thought, but a continuity, a repetition strong enough to last across everything that would follow. And if this much can persist, if even silence can give rise to echoes that last for billions of years, then what else might Earth still be carrying beneath its patient skin? What other mysteries wait, not forgotten, but waiting to be asked again?